And we are recording. Perfect. So once again, hello everyone. Thank you for joining the next rendition of our Forge Online Bootcamp event, this time organized as a pre-event for the Autodesk University 2022. My name is Peter Bros. I recognize some of the names in our attendees list. Not all of them. So for those of you who don't know me, I'm a Forge developer advocate. We are a team of developer advocates spread around the globe, and our job is to provide technical support for developers who are interested in using the Autodesk Forge platform. We're running this event really to help developers who are just getting started with Autodesk Forge and who maybe are more comfortable with a more guided experience when going through the initial learning phases. Some developers, we understand, are fine with reading tutorials, following tutorials, reading sample code on their own, while others prefer to have a more live and guided approach to this initial learning, and that's exactly what this event is for. The format of the online bootcamp is the same as it was in the past. It's a 4-day event where every day we cover a different topic, a different Forge tutorial, and we're running the same webinar for our European audience, and then later for our American audience as well. And also for some of the topics, we're running actually 2 webinars in parallel for both .NET and Node.js programming language. So as we're starting our first webinar today, my colleague Adam is actually running a webinar at the same time, but covering the same tutorial using .NET language, while in our case, we will be using the Node.js programming language to build our server application. And the way the event works, we really try and make it very interactive, because again, if you want to simply follow a tutorial, you can do so on your own, or you can see some pre-recorded videos. This is really more, this event is meant to be much more interactive. So the way it works is I will be following one of the tutorials, the one that we've selected for our webinar today. I'll be live coding. You'll see me code and you'll follow my steps. So I'll try and explain everything in enough detail so that you can follow my steps and build the same application yourself. And if you run into any problems, or if you have any questions on the topic along the way, you're free to ask in the Q&A or in the chats, and I'll do my best to monitor these as I code through the tutorial, and I'll try and make sure that I answer these as soon as possible to unblock you so that everybody can actually follow along. All right. The webinar itself, or all the webinars this week, will be recorded, so don't worry if you miss something. You can always go back to the recording. These are usually shared after the event, so sometime next week I'm thinking we might have the recordings available on YouTube and ready to share with you. Okay, for this week, what we've prepared is again a collection of 4 tutorials that we'll be covering today, tomorrow, and then Thursday and Friday. We're choosing we're trying to choose the more modern tutorials while finding ones that are relatively simple so that we can cover them within the time span of a single webinar, which we are thinking is probably going to take around 4 to 5 hours, with including breaks. And for today, we'll be working on a tutorial we call Simple Viewer. That's really one of the most basic Forge applications that our customers typically build. It's a web application where you'll be able to upload designs, have them translated by Forge, and where you'll be able to preview them in the Forge Viewer JavaScript component. It's a pretty basic application, but it's a really good starting point, especially then if you want to start building on top of it, right? So you can start with this type of application, like a design preview app, and you can then start adding your custom value to it. You can start customizing the viewer, for example. That's something we're going to cover on Thursday. in the dashboards topic, where we'll take the application we will build today, and we will start customizing the viewer, adding custom geometries, custom UI, configuring or manipulating the scene and the state of the viewer for different types of custom use cases. Okay, we're at day one, looking at the simple viewer tutorial, and in this particular webinar, we'll be using the Node.js programming language. And this is how the application will look like once we're done building it. So again, it's a very simple interface with just a drop down and a button to upload a design, and then to select one of the uploaded designs and being able to load them into the viewer and use some of the built-in functionality such as measure tool. Okay, as for the schedule for today, for the webinar today, in the past, what we did is we typically had a fixed set of slots where, for example, we had a 1 hour slot to cover the first part of the tutorial. Then we took a quick break, like a 30-minute break. Then we covered another part of the tutorial. Then we took another break. Now we want to keep this much more flexible, because again, if we really want to make sure that the timing and the tempo of the webinar today will really be driven by you, by the audience. So I think really take this agenda as really approximate, right? We really want you to drive to set the tempo. So when you want to take a break, we'll take a break. I'll try and ask frequently about feedback, if everybody's doing all right, or if anyone's stuck on any problem, and then we can vote on when we take a break and how long that break will be. So really want to make it much more flexible and driven by you. All right. If there are any questions on the format, please ask away now. Otherwise, we can move to step number 1, or segment number 1, which will be really preparing our development environment, right? So make sure that we have everything we need to start coding. I don't see any questions, which is good. All right. First of all, what you'll need is a Forge account and something we call Forge app credentials. You can create both of these on the developer portal. That is simply going to forge.autodesk.com. Let me take the link and send it in the chat just in case. This is our Autodesk Forge developer portal. This is where you'll find most of the resources you need when developing with Forge. All sorts of tutorials, other types of events that happen that we organize for people who want to dive into the Forge platform. You'll find information about pricing, documentation on the individual services in Forge, everything. Not everything, but most of the resources you'll find here. Then we also have some additional resources that our team of developer advocates, that we provide, things like some additional tutorials, for example. Those are on a different website, but this is definitely a good starting point and entry point. So what you'll want to do is, if you don't have an Autodesk account yet, you can use this sign up to try Forge button to start your trial. If you do have an account and a subscription already, you can simply sign in. So in my case, I already have my account and subscription, so I'm just going to sign in. And after signing in or creating a new subscription, you will see this applications item under your profile menu, and that will take you to the list of all your existing Forge applications. Now, Your list might be empty if you're just getting started. You can see in my case, I already have a couple of Forge applications available here. Now, what do these applications mean? A Forge application is really just a configuration for a specific type of product you would like to build using the Forge platform. It's really the most important part of an application generated on this portal is just a set of credentials that we call a client ID and client secret. And you can think of these as the username and password of your application that you will be using, that your application will be using when communicating with the Forge servers. That's really what the applications are all about. This is not actually creating any code. This Forge application is really just creating a record in the Forge platform about some type of application that will eventually be communicating with our Forge servers. You can see, for example, if I open my first app record here, you'll see that the information I get here is general settings like my application's name and description and callback URLs. This is something we will be covering tomorrow when talking about building applications that can actually access your users' data from other Forge-based products such as BIM 360 or Autodesk Construction Cloud. Here for each page, you can also, for each application, you can also choose what Forge APIs this application should have access to. So you can also use individual applications to have a more fine-grained control over what the application will be able to access in Forge. But again, the most important parts are the client ID and client secret. Those are your application's, again, username and password. And eventually, when you start running your Forge application, the applicant will need to provide this client ID and secret to Forge to authenticate itself. And it's also good to use applications to really separate products, right, that you might be building in the future, where if you're building one type of product on top of Forge, you might create one specific application for it, give it some specific, enable certain APIs that you want this application to have access to. And you will even be able to monitor, let's say, the consumption of flex tokens the usage of the different services by that one particular application, right? So it's good to create different applications for different products that you might be building using Forge, again, to have more control over what APIs the application has access to, how many services it's using, and how many flex tokens it's consuming, for example. All right, what I'm going to do is, in my case, I'll create a new application, and I would advise you to do so as well. We're going to create an application that we're going to be using for our tutorial today. So I'm going to say create a new application. I'll give it some easily recognizable name. So maybe I'll say Online Bootcamp Day 1. I'll create my app. And that's it. Now my application is ready. I have another set of credentials, client ID and client secret, and this application is ready to be used. By default, it has access to all the APIs. I think that's fine for now. You can just have all the APIs, leave them all enabled, even though you may not use them for now, but maybe in future, some of these you may want to experiment with. And that is it. We have our app ready. Let's keep this page open because we will use the client ID and client secret soon. We'll need to set these parameters to our Node.js application so that, again, it can authenticate itself to the Forge servers. So I'm not going to close this page. I'm going to leave it open for now. We can go back to our slides. And now for the dev environment, as we said earlier, the language we're going to be using today is Node.js. I mean, the programming language for the server side when building our simple server application. We're going to be using Node.js. That's a very popular server programming language nowadays. It's basically JavaScript, the same language you would use in the browser, but this one is actually running, can run on as a as a desktop application or as a server application, having access to all the different system, like a file system and everything. And I would recommend, if you don't have Node.js installed, we definitely recommend using the LTS version. That stands for long-term support version. If I follow the link, let me again paste it in the chat to make it a little bit easier for you. You should see that the long-term support version now is 16.17. So if you don't have Node.js installed already, I'd recommend that you install the 16.17. If you do have Node.js already, I think the tutorial that we're going to be using today should be fine, should be running fine for older versions, for 15 version of Node.js as well. But if you have like a really old version of Node.js, like a version 10 or 11, I'd recommend that you upgrade to a newer one. And by the way, since, again, I'm working with lots of Node.js samples all the time on a daily basis, if you if you think that you're going to be spending a lot of time developing in Node.js, I would certainly recommend using a utility called NVM. NVM is a node version manager. So this is a very helpful utility. Again, let me send it in the chat, that you can use, that Node.js developers often use to switch between different versions of Node.js on the same system. So I do have this utility installed on my MacBook, and with this I can quite easily switch between, like, I need to test a sample that was written for Node.js version 15, so I can very easily switch to Node.js version 15, and then I can go back to version 16.16 or 16.17, and then maybe in the future I want to experiment with some bleeding edge functionality in 18.9. I can use NVM to switch to NVM to Node.js version 18.9 and then come back. So just an FYI, if you think that you'll be spending a lot of time developing with Node.js, I definitely recommend that you take a look at the NVM utility here. All right, and for the actual code editor, in this case, we'll be using Visual Studio Code. Now, again, this is by no means a requirement. You're free to use whatever code editor you're most comfortable with. I really like VS Code. It has some, I believe it's probably one of the best editors, especially for web development, when you're developing server apps and web front end. It's quite lightweight. I call it the smaller brother of Visual Studio proper. So again, for our Node.js tutorials, I typically use, and I recommend using Visual Studio Code. You're free to use other editors with just a small caveat where maybe some debugging setup you will need to handle on your own, right? So as we're developing our application today, I'll show you how you can debug the server app, the Node.js application in VS Code, right? If you're using your custom editor, then you'll hopefully you have some idea about how debugging works in that case, right? Or for example, how you can set environment variables for debugging your application. Because again, I will show you how to do that in VS Code. If you're using WebStorm or any other code editor, the setup will be different there. But in that case, unfortunately, I won't be able to help you with that. All right, so VS Code, you can find it on code.visualstudio.com. It's a free open source cross-platform editor which itself is actually built using web technologies. It's quite nice. So again, I definitely recommend, if you haven't tried it, I definitely recommend you give it a shot. And you can simply download and install the stable build for your platform. So in my case, I do already have Visual Studio Code installed for my Mac. So go ahead and download and install Visual Studio Code on your machine. And when it's installed, it should look something like this. It's a simple interface where you have just a file explorer, a sidebar for searching through your code, a sidebar for source control. So when you're developing applications using Git source control management, you can use VS Code for switching between branches and checking code in and committing code. All that I do, again, on a daily basis, only using Visual Studio Code. And one interesting thing that you may not be aware of is the Autodesk Forge extension that we've developed. So Visual Studio Code, apart from other things that it does really well, it's also very easily extensible. It's quite nice and easy to write extensions for VS Code. And we use that opportunity to build our own VS Code extension that can actually be used to access your data and Forge services with your Forge app credentials. So if you decide to go with VS Code and you don't have this extension yet, I'd recommend that you go to this extensions sidebar and search for Autodesk Forge. And somewhere towards the top, you should see the Autodesk Forge Tools extension. This is what it looks like. It actually adds some more functionality to the sidebar where you'll be able to upload files, translate and inspect data in Forge and trigger translations in Forge and do all sorts of things. So in my case, I already have the extension installed. You can see it here in the sidebar. If you don't have it, I'd recommend that you install it. And when you install it, you try and open it for the first time, you may get a message saying Forge credentials are missing. Configure them in VS Code settings. This basically means that you're starting the VS Code extension, the Forge extension in Visual Studio Code. So the extension is trying to get access to your Forge application's data, but in order to be able to do that, the extension needs to authenticate itself to Forge, right? That's where the client ID and client secret come in play, because at that point, we need to somehow let the extension or any Forge application know what are the Forge application credentials, again, the client ID and client secret, that the app could use to authenticate itself. Otherwise, Forge, of course, will refuse to answer any requests, right? If the application is not able to authenticate itself. All right, so what I'm going to do is I'm going to hit this Enter Forge Credentials button, and now I'll be prompted for a couple of things. Now, the extension is asking me for Forge client ID, right? That is the client ID from our Forge portal where we created our application. I'm going to copy the client ID, paste it here. Now, the extension is asking for a client secret. I'm going to go back here and copy it. Now, one important thing, just like with passwords, you should not share client secrets with anyone, right? Here, of course, I will expose my client secret because you will see me copying it into Visual Studio Code, right? And this webinar is being recorded, so it'll be out there for everyone to see, but that is all right because I can regenerate the client secrets later on. This is my client secret. Now the extension is asking me what region in Forge I'm planning to use, because just like with AWS, for example, you can use Forge in different geos. So I'm going to say, let's say US as a default, and I'm going to give the Forge app credentials some sort of name so that if I have multiple of these configured in my Visual Studio Code, I can easily recognize them and switch between them. So I'm going to say my env, like let's say my environment. All right, and in the meantime, I see I have a comment in the chat. Okay, if this pop-up doesn't show up, where you can find it is simply in the Visual Studio Code settings. So on Mac OS, I would go to Preferences and Settings. I'm not entirely sure where exactly that will be on Windows, but you basically just want to go to the menu of VS Code and find a way to open Settings. And inside the settings, you can search for settings related to Forge. If I simply type in Forge, I'll see a bunch of settings that my Forge extension is exposing, things that I can configure. And the one thing that the piece of settings that's important is this Forge environments. If I open it, now it's a JSON file, so there is no UI to edit it, but that's fine. You can simply say, use this edit in settings.json link, and that will open. This is basically a JSON that contains my settings for Visual Studio Code. And in your case, you will probably see this autodesk.forge.environments field, which will be an empty list. And you can start creating as many environments for the Forge extension as you want, right? So this is the one, my env, that I just created using the pop-up. So this is the client ID, client secret, and I can create more, right? If I have more applications, I can create another record, give it a different name, another env. Maybe I have a different Forge application, so I'll be using a different client ID and client secret, or maybe different settings. Maybe I want to have one environment for US geo and maybe another environment using the same Forge app credentials, but using the EMEA geo. For now, let me delete this. I just need one environment. And with the settings in place, I hope that answered the question. Oh, perfect. I have my extension configured. And now if I switch over to the Forge icon in the sidebar, you'll see that I suddenly have this additional information available, things like buckets and derivatives, hubs and derivatives, and more stuff. This is really your portal into your Forge services and data. For example, here in buckets and derivatives, for now, I don't see anything, but I could use this plus button to create a new bucket where I can upload files to and then translate them and view them in Forge Viewer. Something we're going to be implementing today, right? So here you actually have this functionality available already without writing any code. So we will build an app that will allow us to upload a design to a bucket in Forge, translate it for viewing, and then preview the output in Forge Viewer. All of that you can actually do here as well. But we're going to skip that for now. We can use this Forge extension in Visual Studio Code later for debugging. For example, if something doesn't work, you upload a file and it's not showing for some reason, right? You can always come back here and you'll see your list of buckets and list of files in these buckets. And if those files are translated, you will even be able to right-click them and say preview, and you'll be able, and the extension will open Forge Viewer right inside the code editor and give you a preview of that design, and that sits in the bucket. All right, that is for the dev environment. We have our application credentials, client ID and client secret. We know that we're not supposed to share the client secret with anyone. This is again, like your password. Hopefully you have Node.js installed. And by the way, to make sure that you have the right version, it's probably good to test it out in a terminal. So if you're using a Linux or Unix-based system, you might already have access to a terminal. And here, in my case, for example, if I type Node-v, you see that I'm running a version 16.16. Also, since I'm using NVM, I can say NVM use 16.17. I can install it. Oh, I can install it first. And then I'll be able to say NVM use 16.17, and I will switch to that particular version of Node.js on my machine. Now, if you're on Windows and you install Node.js, it should come with a Node.js command prompt as well. So somewhere in the start menu on Windows, when you search for Node.js, you should see command prompt there. And when you open it, you'll have a terminal that will look kind of like this, where you'll also be able to type Node-v or npm-v. Now, npm is something I didn't mention yet. npm is a utility that is typically installed together with Node.js, and it's a node package manager. So it's a utility that can be used to manage dependencies for your project. So as you're building your own server application, maybe you'll want to use some third-party library for it. Maybe some third-party library for SDKs for Node.js, or maybe you'll want to use a third-party library for developing web servers or web applications, right? Those will be installed using the Node Package Manager, NPM. So hopefully everyone is all set. You have either access to a terminal or to the Node.js command prompt on Windows. And when you open the command prompt and you type Node-v and npm-v, you should hopefully see the same output as I get in my terminal. So please give it a try. Let me know if you have any issues, if you can't find the command prompt, or maybe if you're getting a different version number, please let me know. And so that is for our Node.js and npm versions, and Visual Studio. Again, I have the stable build installed, and optionally, as I was saying earlier, this is not a requirement, but I definitely recommend checking out the Forge extension for Visual Studio Code as well. All right, so everybody doing well? Can you give me a thumbs up if everybody's all set? Again, I think there should be, oh, perfect. I don't see it in the attendees list, but I see some thumbs up outside of my Zoom window. So, right, okay. So it looks like hopefully you guys are all set with our dev environment setup. So now comes a question. What do you want to do next? Do you want to continue straight away, or you want to take a quick break? I was thinking we could try something. Let's create a poll. Can I create a poll? Simple poll, okay. What to do next? A single choice. So let's say take a 30-minute break, take a 15-minute break, or continue straight away. Okay, so, and I can launch the poll. So please let me know. We can decide. I'll just follow the majority. Okay. Oh, it's 50-50, taking a 15-minute break and continuing straight away. Let's see if anybody else will tip the scales. Now we have a slight majority for continuing straight away. Let's wait for a little bit more. Screenshot. Okay, so let's end the poll. And there was a slight majority for continuing straight away. So hopefully that is all right with the rest of you. Some of you voted for a 15-minute break. So I think let's find a compromise. So let's cover the next step of our tutorial. We can bootstrap and scaffold our application, and then we can take a break for all of you so that people can catch up and go grab a coffee. I think I'm going to go grab a coffee for myself as well. Okay. And we're moving to the next step, that is scaffolding our server application and implementing the authentication. Again, that is the process of setting up our application so that it can authenticate itself to Forge, so that Forge knows who that application is and who it belongs to, right? Then Forge will know that this application, these client ID and client secret credentials, actually are linked to your email, to your account, so that later you can see the usage of your application, see how many tokens it might be consuming, for example. Okay, this is a very simple diagram explaining how the client-server application works. We develop a simple server application that will be our connecting point to the Forge platform, so that typically you want to have some sort of a proxy. You don't want your web page communicating directly with Forge, because then that could be potentially a security hole, where if somebody somehow gets access to your authentication tokens on the web page, they could start communicating with Forge, sending different requests to Forge, other requests than you originally intended. So it's always good to have a server application in place acting as a middleman, where your web page will always only communicate with your server application, and your server application will then decide what types of calls can be made to the Forge platform, right? So for example, as we develop our application, we will want to get a list of files in one of our buckets. So instead of requesting this information directly from Forge, we will instead make this request to our server. We will request the list of objects that we want to show in our application from our server, and the server will then decide where to grab this list of designs from, right? Which bucket it should get the list from specifically. Maybe your application could then also have some sort of custom filtering to only show a subset of these designs to the web client, right? Maybe you want to have some special filtering per user or per project. That is completely up to you. So when requesting a list of designs, for example, the request will actually go from our client web page to our server application, and the server application will in turn request the data from Forge. And for some types of data, for example, for the actual conversion output that you want to preview in the viewer, there is an exception. This data will actually be requested directly from the Forge model derivative service, but that is only for the viewer itself. All right, so let's start setting up our Node.js application. What we'll do is first, we will initialize a new NPM project or a new Node.js project using the Npm, the Node Package Manager utility, and we will install some of the dependencies that we'll be using. And what I like to do in my samples is whenever my application needs to collect some sort of configuration input, some environment variables that configure, let's say, the Forge client ID, client secret, maybe some other types of input parameters that you want to use before your application actually runs. I like to collect these in a single file, let's say config.js. And then I'll also show you how you can create something called a launch configuration. That is a concept in Visual Studio Code where a launch configuration is basically information about how Visual Studio Code can run and debug your application. And then we'll create a server.js file that will be our actual Node.js server, and we'll test the whole thing when we get to that point, just to see that the server app can actually start and run, and that we can connect to it from Visual Studio Code and debug it. And by the way, one thing I did not mention, that was quite an omission on my end, is that we're going to be following the simple viewer tutorial. Is actually the source code for it is available on GitHub. If you head over to github.com/autodesk-forge, this is our official GitHub organization where we share most of our SDKs and samples. And the one called Forge Simple Viewer Node.js is the one that we're actually going to be building today. So let me share that link with you in the chat. And if at any point during the webinar today or after today's webinar, you maybe get stuck on something or something is not working right for you, you can always come back to this source code as a reference, because this is what we're going to be building. And also, you can actually find a tutorial that will guide you in building this sample app on our Forge. Oh, I was typing in the chat. Forge tutorials, autodesk.io. Okay. For some reason, I can't type in the chat. It's really strange. Okay. I go to Zoom. Now, okay. So forge-tutorials.autodesk.io. This is the website that includes the tutorial that will, one of the tutorials that we'll be covering today. If I look at Simple Viewer, tutorial Simple Viewer. This is really a tutorial that you can follow along on your own, or that you can, the one that I'll be live coding through today, so that you can actually follow along with me and ask questions along the way. So our Simple Viewer application, we're now at the application setup phase. I want to switch to Node.js because in our webinar, we'll be using Node.js and Visual Studio Code. All right, so creating your application in Node.js, this is typically done from the command prompt or from a terminal, where you simply create an empty folder, and inside that empty folder, you call this npm init command that basically will initialize your Node.js application. So that's what I'm going to do here. Since I'm on Mac in my Unix terminal, I'm just going to say mkdir, let's say day one. I'm going to switch inside that folder. And again, in your command prompt on Windows, or you can create an empty folder somewhere on your system using a file explorer on Windows Explorer. And then you can, when you open your Node.js command prompt, you should be able to cd into that folder. And once you're in the newly created empty folder, simply type in npm init or npm init -y. -y will basically say answer all questions with default answers, because simply running npm init will ask for a couple of questions. Things like, what's the name of the package you want to create? I'm just going to leave it at day one. What's the version of the package that you're building, the application that you're building today? I'm going to say it's the default 1.0.0. Any description, I can skip this, entry point, test command, author, license. I'll leave this the default. And if you run the npm init -y, this will just answer all these questions with default answers for you. And now when that is ready, you should see one file in your new folder called package.json. Let me explain what this file does. I'm going to go back to Visual Studio Code. We'll say open folder. And I will navigate to my newly created folder and open it. Right, so I've opened the day one folder that I just created, and where I ran my npm init command, and I'll say open. VS Code will also ask you if you trust the authors of these files. You can just say yes. And this is what you should see. You should see your folder name as this expandable arrow here in the file explorer. And under there, you should only see a single file for now, and that's the package.json. And this is basically the metadata for your Node.js project that was created by NPM, right? So any kind of Node.js project that you're building, whether it's a server application, whether it's a command line utility, whether it's a, a library that other Node.js projects can be using, all of these will always have this package.json file that describes what the Node.js project actually is and what it depends on. So you can see some of the standard properties like name, version, description. These are actually the questions that npm init command was asking me for. And you can also add, in future, you can also see additional properties here, such as a list of dependencies, all the other external Node.js modules that this Node.js application depends on, or that it leverages. All right. So far, this doesn't look very exciting, but we'll get there. So we have our Node.js application package.json file ready. Let's go back to our slides. What we'll do next is install dependencies. So in our case, our application will need a couple of things. It'll need Forge SDKs, because typically when communicating with Forge, most of the Forge services are just web services that you can send HTTP requests to and get some response. But that is quite low level. You don't want to keep building all the HTTP requests and doing all, making sure that all the payload of the requests is properly structured, and then cherry pick the data out of the responses that come back from Forge. To make this easier for you, we provide Forge SDKs for some of the most popular programming languages, including .NET and Node.js. And that way, you can simply make requests to Forge in form of a method call. And that method call will, under the hood, take care of building the HTTP request, building the payload for the request, sending the request, retrying if possible, and then extracting the data from the response, right? Every method call using the Forge SDKs will do that for you so that you don't have to go that low level. So we will need Forge SDK for Node.js, and we'll also need an Express server, Express framework. Let me explain what that means. And by the way, again, you will see all of that in this page of the tutorial. You can see here we're calling Npm Install Express, Express Formidable, and Forge APIs. So we're actually installing 3 dependencies. Express is Node.js framework application. So as we will build our server app, the server app will need to listen for specific requests on specific URLs. For example, if we send a request to our server application to an endpoint that says, I don't know, /API/models, the server will need to respond with, let's say, a list of models that we want to show in the dropdown eventually. This could also all be done using vanilla Node.js, but it would be unnecessary, some unnecessary work, extra work. Instead, we can use something like Express Node.js framework, where, and with the Express framework, building a Node.js server will be much simpler. It'll handle, some scaffolding work for us so that we don't have to worry about that. So Express is one of the dependencies that we're going to be installing. Then also the Express-Formidable. This is another third-party utility. If I search for Express Formidable on NPM, that's the Node package manager. This is actually the registry of all the different third-party Node.js modules that you can install. You'll see that this is a Express, something called middleware. It'll be used for handling multi-part form data upload. Because eventually in our application, we will want to be able, from our web client, from our web page, to upload a file to our server application, translate it in Forge, and prepare it for viewing so that we can later load it into the viewer and preview it in the viewer. And of course, the server, in that case, will need to somehow be able to accept file uploads from a web page. That itself, again, is not a trivial thing, right? So when a web page is trying to upload data to a server, it may use different types of encoding, different ways of uploading the file itself. The multi-part /form data is a common one, and that's the one we're going to be using in our server. So by installing this Express Formidable dependency, it'll be easier for us to implement the upload capability in our Node.js server application. And finally, Forge APIs is another NPM module, and this one is actually developed by us, by our team. This is the Forge SDKs for Node.js. And this will be the Node.js module that you'll be using for actually making requests to Forge. For example, when uploading a file, or when asking Forge to translate a specific file, or when asking Forge to get a list of all designs uploaded to a specific Forge bucket. So these 3 dependencies we can install now. So let me go back to my terminal, or to, in your case, to your Node.js command prompt if you're on Windows. And here, what you'll want to do is type npm install, and then just the list of dependencies that you want to install. So in my case, I'm just going to say Express, that's the Node.js web framework. Express Formidable, or Express-Formidable, that's the NPM module that will help us build the upload capability in our server. And Forge-APIs. This is the Forge SDK for Node.js. When I do this, this may take a while. In a moment, you'll see that the process is complete. And now if I go back to Visual Studio Code and open the package JSON file one more time, you'll see that our package.json file now actually has a list of dependencies with some special version symbols. This is actually quite useful because what this means is that if we then later take our source code and share it with somebody else, that other person, they can simply, inside this folder in terminal or in command prompt, they can type npm install without anything else. And simply typing npm install, the command will look at the package.json file. It will check what the dependencies are, and it will install these dependencies automatically, right? So you don't need to tell the other person that you're sharing your code with, oh, by the way, you will need to install Express and you will need to install Forge APIs module, right? All these dependencies are captured inside the package.json file. And the special symbols you see here are, this is a special syntax for versions, right? So this symbol in front of a version number. So this is the standard major, minor, and patch number. And this symbol basically says this version of Express is required, or any newer version that's backwards compatible. So that would be, in this case, would be 4.anything, right? So later on, if maybe Express has a new version that's 4.19, there is a convention that 4.19 version should be backwards compatible with 4.18. And that's why when the other person that you're sharing your code with, when they run npm install, the npm install may actually grab 4.19 instead of 4.19. If I remove the symbols, the caret symbols, this basically means that this project that I'm building here depends on exactly these versions. I don't think we need to go into too much detail on that. Again, this is something called semantic versioning. If you're interested in maybe learning more about this after the webinar, but for now, I think it suffices to say that the dependencies here, we basically specify what npm modules our application depends on, and we specify the exact versions that our code depends on, so that there are no issues later if somebody wanted to run our code with different versions of these dependencies. And you can now see that there's actually a couple more items in our folder. There is a node modules folder. This is typically a quite large folder that contains a flattened list of our dependencies and all their dependencies, right? Because the Express framework might have some dependencies, and one of those dependencies might have its own dependencies. So all these, this tree, dependency tree, is flattened and stored inside the node modules folder. So this is something you definitely don't want to include in GitHub because it's just too much data, right? This is just like a local cache of Node.js npm modules that when you share your code with someone, you just need to make sure to include the package.json file in your source code that you're sharing with them. And then they can run npm install on their own machine, and the npm will create the node modules folder on their own system with their own cache of the dependencies. And package log is a relatively, it's a newer thing, a concept that was added to npm, where this package log JSON file actually captures the exact versions. If you happen to include the caret symbols, as they were originally there, if you then, the package log, this basically means that our project requires this dependency version 1.2 or anything higher, 1.3, 1.4, 1.5, or 1.5.6. In that case, to make sure that really everybody's working on the same set of dependencies, the package log file then includes the exact versions. So, right, so even if we say that we depend on Express version anything, 4.anything, or 4.18 or newer, this means that this can actually match multiple different versions. Then the package log will include the exact, let me find it here. Express, here we actually, the package log file will capture precisely the version that we're using in our case, and that is the 4.18.1. So again, I'm probably not going to go into too much detail that might be unnecessary. And I have a question. Will you share the script at the end of the training day? And if by script you mean the actual code that we'll be building today, I will, but it's actually the source code that you can find on GitHub. So when you go to Forge tutorials, again, look at our simple viewer. That's the application we're building today. You'll see that there is actually a link to GitHub with full implementation of this sample, right? So if somewhere you run into an issue or the application is not running as expected after the webinar today, you can follow this link to GitHub. And here you can use this as a reference, right? So this is actually the final state of the application that we're going to be building today. Share this one more time. I hope that answers your question. Okay, so we've got our dependencies, our node modules folder. So let's go back to our slides. Now we're going to create the config JavaScript file, where we will collect all the input configuration for our application. I'll go to the application setup. You'll find the application config section here. So we'll be creating a config.js file, again, that will try and read some important configuration from the environment, as we call it. And in this case, you may see this process.env. In Node.js, process is a global variable that represents the actual operating system process that our application is running in, right? So, and then with information such as process.env, we get access to, in this particular case, to environment variables that were configured for our application. So process.env will be an object with keys representing individual environment variables and values representing the actual content of the environment variables. And this syntax that you see here, if you are not recognizing it, this is something called destructuring in Node.js. So we could type, so let me go back to our source code and create a new file called config.js. So this is going to be one of our JavaScript files in Node.js. In this case, again, we'll be collecting configuration data from our process where our app is running. Now we could do something like, let's say we want to store the Forge client ID environment variable. We could say something like Forge client ID equals process.env Forge client ID. And then we could say let Forge client secret equals process.env Forge client secret, but it's quite chatty and unnecessary. Instead, we can do this. Let curly braces equals process.env, and by this, when we use the curly braces on the left side of the equal sign, we're basically destructuring the env object and only cherry picking some of its properties. So when we say Forge client ID and Forge client secret, we're basically defining two variables, Forge client ID and Forge client secret, and we store data from this process.env object into them. So we store process.env.Forge client ID into a variable called Forge client ID. And similarly, we store the process.env.Forge client secret value into the Forge client secret variable. Now there's going to be more that we want to store, also forge bucket and port. Forge bucket, because when we run our application, we will want to be able to configure it to tell it which forge bucket it should actually upload data to and list the designs from. So this will be an optional variable, but we still want to try and read it from the environment. And finally, port. This is quite helpful when you want to deploy eventually your application somewhere, to Amazon, to Heroku, to Azure. When you're running your application in different environments, you may need your application to listen, your server application to listen on a different port. When we run locally, it's you typically set up the port that your application listens on to be something like 3000 or 8080 or something like that. But then when you deploy in future, when you deploy your application somewhere to the cloud, the application may actually need to listen on a custom defined port number. So that's why it's a good idea to try and read the port environment variable from the process and use it if it's defined. Now, some of these, like the forge client ID, forge client secret, these environment variables are required, right? Because without these, we won't be able to run our application, or I mean, our application won't be able to communicate with Forge. So these two are certainly required. And what we can do is, let me just copy the rest of this code from the tutorials page. We can simply say if forge client ID is not defined, or if forge client secret is not defined, issue some warning and exit the process, right? So here we once again use the process global variable, and we call a method called exit, which takes an exit code. So if we get inside this if condition, we will just report, hey, by the way, you're missing some environment variables that we need, and we will exit the process. We will exit the application with exit code 1, and any non-zero exit code basically means something went wrong. And then what we do is we check if the forge bucket is provided, the environment variable, and if it's not, we create a new name for a bucket. So basically we say if whoever is running our application did not provide the forge bucket environment variable, we're going to create a new one by taking our client ID, forge client ID, turning it to all lowercase characters and adding -basic-app. So if my forge client ID is, I don't know, 123 ABC, right? We will create a new bucket called 123 ABC -basic-app. Now, why we're doing this? It's because the bucket names must be globally unique. I can't just have a bucket called test, because it's very likely that somebody has already created this bucket name in the past. And again, there would be a conflict because the bucket names appear in URLs, and that's why they have to be globally unique. So whenever you're creating a new bucket, you need to figure out a name for it that you know will be unique, that is not already used by somebody else. If you try and create a bucket with an existing name, you get a 409 error from Forge saying there is a conflict, this bucket already exists. And similarly for port, we try and see if port number is defined, and if not, we default to like one of the typical port numbers that are used for local development. And in this case, we use 8080. So then later on, when we want to open our application, we will go to localhost 8080, because our application will be running on localhost, listening on this particular port. All right, and finally, we grab the variables that we've defined here in our script, and we export them from this JavaScript file so that we can later cherry pick these values in another Node.js file. That's how basically Node.js imports and exports work among different JavaScript files. When you write a JavaScript file, you create basically like a module, and then you define what values or methods should be exported from this file. And then in other files, I'll show you in a moment, you can then use this require method to import some of these values. in another JavaScript file. All right, so this is our config.js file. And next, this is specifically for those of you who decided to use Visual Studio Code. Next, we're going to create a launch configuration. And the way to do that is in VS Code, you can go to this run and debug section. And for now, you won't see a lot here because there is no launch configuration defined yet. But you can, from here, you can say, create a launch JSON file. And in this case, VS Code will ask you what type of application you're planning to debug. So in our case, we know it's Node.js. So I'm going to say Node.js. And if I go back to my file explorer, you will see that this action created a new folder in my project called .vscode with launch.json file in it. Right, and here you can see we already have a list of configurations, these launch configurations, with just one defined inside it. And this launch configuration in particular, it says, okay, it's a Node.js application. And when debugging it, I want to start some specific JavaScript file in my project. Now, the only JavaScript file it was able to find for now is config.js, but that's definitely not the file we want to run. So I'm going to change this to server.js, because eventually we'll create a file called server.js here, and that will be the entry point to our application. That will contain the actual logic for our Node.js server app. Now, another cool thing is you can add some additional parameters to this launch configuration. For example, are there any command line arguments that should be passed to this project when to this application when it is debugged? Or are there any environment variables that should be set when this application is debugged? You could either say env, and here you could then provide your environment variables, or another option that I prefer is there is an env file property that is automatically set to my workspace folder /env. So if I create a file here in my root, call it .env, I can start specifying all the different environment variables that I want to use when debugging the app, right? So in this case, let's say which bucket, something. Of course, again, this means that this .env file you should not upload or submit to GitHub, right? You don't want to include this .env file with your source code because this will, again, contain the sensitive data such as the Forge application client secret. So if you plan then to share this code or send it to GitHub, it's always a good idea to exclude this .env file from GitHub. There are ways to do that using .gitignore files. You can learn more about that online as well. I don't think, again, we have time to cover that here. So just so you know, so we have our launch configuration set up. VS Code now knows that when we run this configuration, it needs to start Node.js with this file, server.js, and it needs to load environment variables from this .env file and make these environment variables available to our debugged application. All right. And finally, we're about to build our server application. And at its very basic, it will look like this. We will simply import. This is going to be importing of methods and classes and variables from other JavaScript files, right? This is using the require syntax. So saying require basically means import something from other JavaScript files or from other npm dependencies. So in this case, we're saying, okay, we have an express dependency that we installed using npm, And we want to import this dependency into our server.javascript file. And also, when using this relative path syntax required /config.js, we are importing one of the variables that we have in our config.js file, right? And again, here we use the destructuring syntax on the left. So we say the config.js file is exporting multiple variables, but we're only interested in the port number. That's the port variable. That's the port number where our application should be listening on. So let me grab this code, go back to Visual Studio Code and create a new file in the root called server.js. And what we do here is the import that we bring in from the express dependency is really a function that we can call to create a new express application object. And then this will be our server application that we can then call different methods on to set it up, and ultimately to call the listen method on. When we call app.listen, we basically say, okay, our app is now configured and the server app can now listen on a specific port. And then when it's ready, when it's initialized and ready to accept incoming HTTP requests, we just output information into the console. Now, you see this express.static here. The Express framework also allows you to configure your server application to serve static files from a certain subfolder. What I would ask you to do in order to make this work is in your project folder, create a new subfolder called www.root. That's the name of the folder we decided to use in our Express application setup. And what this means is whenever somebody makes a request to our application for a specific file, let's say if somebody makes a request to localhost/index.html, with this line of code, the Express application will look inside the www.root folder and will try and see if there maybe is a file called index.html. And if there is one, the Express application will send this file back in the response immediately. Or if there will be a file called viewer.js and we make a request to our application to localhost/viewer.js, this line of code again will check if maybe there is a viewer.js file inside the www.root folder. And if there is one, it will serve it. So with this single line of code, express.static, we configure our application to serve any static files inside the www.root folder if the client happens to ask for a file name that actually exists there. Okay. And I believe that is it for the next step. So we have our config.js file where we collect all the inputs from the environment variables. We check those that are required are actually available. And then we export this collected information out of this config.js file so that it can be imported in other files. And that's exactly what we do in the server.js file, where we import the port number and we use it to start our server application. So that application will be listening on the port number from the config.js file. And we've configured our Express application to serve static files from www.root. So this is the folder where eventually we will be storing our client-side HTML, CSS, and JavaScript code, images, and things like that. And then we don't have to worry about individually implementing code that will return these files when the client asks for them, right? This will all be handled by this Express static, something we call middleware. I'll explain that later. This middleware will basically make sure that whenever you make a request that looks like you're requesting a file, the application will try and see if that file exists in the subfolder. And if it does exist, it'll send it back to the browser. All right. So now, when I switch to the run and debug section, you should already see a launch program in the dropdown at the top. That's actually the name we gave to our launch configuration. I can go back to my launch.json file and change this to maybe launch my server app, right? Now, if I go back to the run and debug sidebar, you can see that now it says launch my server app. So you can have multiple launch configurations, give them different names. Maybe each configuration will run the same app with slightly different input parameters, maybe with different command line arguments, something like that. So this is good for testing, for example. All right. That's it. So now we should be able to run our application. And when you run it for the first time, a debug console should open in VS Code. And that's actually the output from our console, from our running application. So you'll see here that we got this message, server listening on port 8080. So this is actually coming from this console log telling us that, okay, our app is now listening on port 8080. And what we can try is open a browser and go to HTTP localhost 8080. And if we make a request there, we don't get a, not found, domain not found or something like that. We don't get the usual browser error. We actually get a message from our application, right? So what happened here is we send a request to our Node.js Express application asking for something, let's say foo.bar.txt. We're asking, or maybe something like this, right? We may send a request to our server to /foo/bar.txt. That's a specific, the foo/bar.txt is a specific endpoint that our Node.js application will try and answer in a certain way. But if we do this, the app simply answers cannot get, because we haven't implemented any endpoint called foo/bar.txt. So our Node.js application does not know how to answer this type of request. So when you see something like this, like cannot get, this is actually good. This is expected because, again, our application is running, but we haven't implemented any logic for it to be able to respond to specific requests yet. All right, so I'm going to stop the application here. This is, you can use this menu at the top when your app is running to pause the execution, restart, or stop. And then, since we're actually using the launch configuration in VS Code for debugging, we can even put breakpoints in our code. So for example, now I put a breakpoint here on line 5 where we're adding the Express static middleware. If I restart my application, you'll see that the execution will stop here. So now the app is paused, right? And I can explore the different variables. So I see that, for example, the port variable that we're importing from the config.js file is set to the value 8080. I can hover the app, the Express app, and you'll see all the different methods and properties that this Express app object includes. So this is something we can use later to debug our application, for example, if something is not running. Okay. And that is it for the application setup. So hopefully you all have been able to follow along. If not, if you ran into any problem, again, ask away, drop me a note in the chat or in the Q&A. I really want to make sure that you guys all can, again, have been able to get to this point, and then later we can continue with the other parts of the tutorial with the authentication, file upload, and translation and viewing. So if you have any questions, any problem, let me know. Otherwise, I think now I would try and make it up for the other half of the voting group that wanted to take the break. And now I would say, if it's okay with you, we could take a 30-minute break, if that's all right with everyone. I'm not sure what time zones you guys are in. For me, it's 11:30 here, so that would I think be good. So I could take a quick break, grab coffee, and then at noon my time, Central European time, we could be back. So does that work for everyone if we take 30 minutes now? I see some thumbs up. Awesome, perfect, cool. And I see there is one question in the Q&A, so I can so you please stay on the webinar. I can help you, and the rest of you, if you don't have any questions, if you're all set, let's take a 30-minute break, and let's get back here in 30 minutes from now. So again, that'll be noon for me, and possibly a different time, say the different time for you. So I'll see you all back here in 30 minutes. Okay. Awesome. Recording is back. Thanks for coming back. Hope you had enough time to grab your coffee, and we can continue. Before we move to the next step in our tutorial, just two things I wanted to cover, something that was discussed here during the break. If you happen to have any issues with running the application, double check that in your launch configuration that you're running the server.js file, right? So the program field in your launch configuration specifies the script that VS Code should run and debug, right? So originally it found the config.js file, but we actually want to run this server.js file. This is the entry point to our actual application. And also make sure that you provide the correct path to whatever file. In my case, I usually call it .env. It can be any arbitrary file name where Visual Studio Code should grab the environment variables from, right? So in my case, I'm using .env, and it sits in the same folder, project folder, as the server.js file. So .env, I have my environment variables here. Now, for now, we can specify any arbitrary values because we're not reading them yet, but it's actually a good idea to prepare these the proper credentials already, as we're going to need them in this next step. So what I'd ask you to do is go back to the dev portal where you created your application and copy and paste the client ID and client secrets into the .env file, or whatever you're storing your environment variables. I'm going to grab the client ID and client secret. And also what I'm going to do is I'm going to delete the forge bucket environment variable, so that if you remember correctly, if you remember in the config.js file, the forge bucket environment variable is not required. And if it's not defined, we will come up with a new unique name for our application's forge bucket just by taking the forge client ID and adding this basic app suffix to it. So now my environment variables are set up correctly. And if I run the app, everything should look as before. And also, there was a question about the way to exclude different files and folders from Git when, let's say, publishing this code to GitHub. If you want to do that, simply add a file to your project called .gitignore. And in this file, on separate lines, you can list file names and folder names that you want to exclude. So usually when I write my gitignore file from scratch, I usually do something like node modules, because that is the folder, the large folder with all the different dependencies that you definitely don't want to sub to Git. These should only be used as a local cache when somebody runs npm install. I also like to exclude anything with the log extension, right? The log extension can sometimes be created, or files with the log extension can sometimes be created by npm command when something goes wrong. So I don't want to include log files in Git either. And here I'm also including the .env, right? So node modules, any files with the log extension and the .env file, all of this will be excluded if I wanted to take this code and send it to GitHub, for example. All right. And I believe, and also one more thing I wanted to add as a convenience. Going back to the package JSON file, right, that we discussed earlier, this is the metadata describing your Node.js application, including things like what version it is, what dependencies it has, who the author is, and things like that. There's also this property in the package JSON file called scripts. This is quite useful, as here is where you can predefine a bunch of scripts that you can then run that will do different things. So for example, what's quite common is to define a script called start. And inside the values, you specify whatever command you want to run when somebody types npm start. So for example, you know, as the author of this project, that server.js is the entry point to your application. So you know that in order to run this app, you actually need to type, node server.js, right? But whoever else sees your code, they may not know that server.js is the entry point to the application. So they maybe would not know how to run the app. And that's why in NPM, it is a convention that npm start script should be the one that starts the application, right? So if I'm somebody else coming to the source code, I haven't seen it before, right? I can at least look at the package JSON, or I can just go to a terminal and start and type in npm start right away. And if I type npm start, the npm utility will look inside the package JSON and we'll see, oh, there is a script called start. There can be another one called, I don't know, that, another script, let's say called foo, that maybe you would want to run, right? And npm will simply try and locate the script inside the package JSON file and run it for you. And npm run start, or you can actually shorten it to npm start, will do whatever the start script in the package JSON file says it should do. Of course, now, one thing you keep in mind, if you run the application this way from the command line, it will say missing environment variables. Why is that? That is because if we simply run the npm start script from the command line, we're running Node with the server.js file, that's correct. But since this is not running from Visual Studio, this is just a simple terminal, Visual Studio is not setting the environment variables that it needs, that the application needs, right? So if we wanted to be able to actually run the application from a terminal, whether it's your command prompt or the terminal inside Visual Studio Code, you would actually need to specify the environment variables in the terminal before running the app. So again, if I just type npm start, it'll say, missing some of the environment variables. Now, this setting the environment variables will again depend on the operating system that you're on. But in case of a Mac or any Unix-based system, you would use something like this. Forge client ID equals something. Forge client secret equals something. And now you have these two environment variables specified. And now if I run npm start, it actually starts the application, because now the app was able to read these two required environment variables from the process. If you're on Windows, I believe that you would have to use the set command, where you have to be set forge client ID equals something. I believe this is the command for command prompt on Windows. This is how you would set an environment variable on Windows. Or you can, I think there is a UI interface in Windows where you can set environment variables as well. So that would be another way to set them. But I think set is the right way if you're using the Node.js command prompt. To just to explain what the start script is doing. And also, it's a good idea to use the start script because let's say in the future you want to deploy this application to something like Heroku, right? Or to Amazon, AWS or Azure. When deploying your app, again, whatever host is running your application needs to know how the application should be run, what script it should be used as the entry point, right? And again, this is where defining the script called start helps, because this is a generally accepted convention, so that when you take this code, send it to Heroku, Heroku will know automatically that it needs to run npm start script unless you configure it to something else. So this is the default. So it's again a good idea to have the start script defined inside the package.json file. Not necessary, but it's good to have it there. It's a convention. It's a good practice, even for just the readability of your code, so that if I take this code from you, I look at it, the first thing I'm going to do is I'm going to take a look at the package.json file, and I see, okay, so in order to start this application, I need to actually run Node with the server.js file. I hope that makes sense. If you have any questions, let me know in the Q&A or in the chat. And if not, I think we can move on to authentication. So now we're actually going to start using the Forge SDKs in Node.js, and we're going to start implementing some logic in our server that will help us handle authentication. And again, that's the process of our application providing some credentials to Forge to authenticate itself. So we're going to implement some helper methods under a folder that I decided to call services. So again, it's a good practice to capture any custom service logic in a subfolder. I mean, we could smash everything into a single JavaScript file. We could smash everything into the server.js file, but then, eventually that file could get really large and really hard to read. So that's why I think it's a good idea to really structure your code and split different parts of your application code to different files based on their responsibility. So what we have today, right now, we have a config.js file where we capture all the configuration input. We have a server.js file that actually implements the server application. And then we will create a folder called services. And under that folder, we will implement all the different helper functions for communicating with Forge or communicating with potentially other services. And we will also create a folder called routes. And this is a convention used by the Express framework, where you typically implement all the different endpoints that your server application can handle and respond to in the routes subfolder. So we'll create a file called services/forward/auth.js, where we'll build some of the authentication helpers, methods for, generating a token, for example, an access token for our code. And then we will have a route/auth file where we will define some of the endpoints that our server application will be able to handle. Nice. So we have a question in a Q&A. Still missing how to pass secret data if I want to deploy the app to Heroku. All right, I'll explain. So let's say you have your application ready and you want to deploy it to Heroku. What you would typically do is you would go to Heroku. And for those of you who don't know, Heroku is one of the available platforms where you can deploy your server application and have it run there for free, but I think they're actually planning to stop the free tier. So starting November 28th, you will no longer be able to run free applications on Heroku. But there are alternatives like Netlify or others that, well, let me log in. All right, so let me try try this one, my Autodesk account. If I go to Heroku, so the way it works is that you go to Heroku, you create an application in Heroku that will create a domain, let's say myapplication.herokuapp.com. You can see I have a bunch of applications created here already. And then you can send your code, you can push your code to Heroku, and it'll just run it for you automatically. Now, of course, if you take the same application that you're developing locally and you want to run it on Heroku, Heroku will somehow need to provide the environment variables that we are providing locally, right? And the way to do that is, if you select one of your applications on Heroku, you go to settings, you'll have this reveal config vars, config variables, right? So if I did this, this would show you a list of key value, where you can insert or modify environment variables that you want to pass to your application. So this is how you would configure your app, your simple viewer application that we're building today, if you wanted to deploy it to Heroku through the settings and config vars. All right. So what I'm going to do is I'm going to go back to our Forge tutorials website, and I'm going to go to the next section, the authentication. Let me send it in the chat. So that's the section we're looking at now. So as I mentioned, we're going to start by implementing some helper code under the services subfolder. So what I'm going to do is I'm going to copy this code and explain what it means after pasting it in VS Code. So it's supposed to be in a file under services Forge subfolders. So I'm going to create a new folder called services. Inside there, I'm going to create a new folder called Forge. And inside the Forge folder, I'm going to create a file called auth.js and paste the content. So now we have our services folder that will contain, again, some helper methods for communicating with different services, be it Forge or eventually something else. And inside the auth.js file, what we're doing here is the following. We're finally using the Forge SDK, right? We use the require syntax to import something out of the Forge API's dependency. So the Forge API's dependency includes a bunch of classes and methods that you can use to communicate with Forge. If we wanted to look at the details, I could Google npm Forge APIs again to find the page of our Forge SDKs in the npm registry, right? And here you can actually find some more information about how the Forge API's dependency module can be used. So we would see that you can bring the SDKs through the require call, right? And you could, for example, use the auth client two-legged class to communicate with the authentication service in Forge. And the authentication service is used to authenticate your application. And the typical process in this two-legged workflow is that your application sends the client ID and client secret to Forge, and the Forge authentication service will respond with an access token, which is a long secret string that has a limited time to live. I think it's only valid for 60 minutes. And you can use this token in all your subsequent communication with Forge until the token expires. Then you can make another call to this authentication service to generate a new fresh token, and then again use it when communicating with Forge. The way that works is what we'll show you in the code. But here, actually, if you scroll all the way down, you will see a complete, I believe, a complete list of classes and methods that can be called and that can be used with this SDK. So, for example, for listing objects in a bucket, we could use Forge objects API class, which has a method called getObjects. And this is equivalent to making a request to this URL on the Forge data management service. So under the hood, this method called getObjects will put together an HTTP request to this OSSv2 buckets endpoint, which is documented on the Forge website. This is the endpoint of the Forge data management service. It'll send the request to Forge, and it'll extract the data from the HTTP response and return it as the return object of this method call. That's why it's better to use the SDKs again, so that you don't need to go low level and create and process the HTTP requests and responses manually. All right, going back to our auth.js file. So we're bringing in one class called auth client two-legged. So again, we'll use this auth client to communicate with the Forge authentication service, and specifically using the two-legged workflow. So just to explain what that means, there are two concepts in the authentication in Forge: two-legged and three-legged authentication. Two-legged means that it's just your application and Forge as the two parties establishing trust between themselves. And then that's the process where your application will send a client ID, client secret, and Forge will respond with an access token that you can then use to make other requests. Then there is the three-legged workflow. This is something we're going to be covering tomorrow in the second tutorial. And three-legged means that there are actually three parties establishing trust. It's your application, your user, and Forge. And the workflow looks a little bit different, because then your application actually needs to ask the user for consent first. And the user needs to say, okay, yes, I want to allow this particular Forge application to access my data in Forge. So in this case, today, we're going to be using the two-legged, the simpler authentication workflow, the two-legged one. So we're bringing in a class called auth client two-legged, and we're bringing in also the Forge client ID and Forge client secret from our config.js file. And of course, we're deeper in the folder structure, so we need to go 2 folders higher, 2 folders up before reaching the config.js file. And then we create 2 instances of our authentication client. Why 2 instances? It's a good practice to separate authentication that you want to be public from authentication that you want to keep internal to your server app. What does that mean? You can see here we have one variable, one client that we decided to call internal, and then the other one we decided to call public auth client. And when we create the instance, we pass in the Forge client ID and Forge client secret, and then you might have noticed these arrays of strings looking like this, either like bucket read, bucket create, or viewables read. This is something called scopes, because as you are requesting an access token from Forge, you can actually specify what types of operations you want to grant to the access token that you're creating. And these are the scopes or operations that you want to allow, right? So we are creating one authentication client for internal use, because this one will generate access tokens that will have the power to read data from buckets, create buckets, read data inside buckets, overwrite data inside buckets, and create new files inside buckets. So the access tokens that we're going to be getting from this authentication client will be quite powerful, right? So again, as a security measure, we want to make sure that these access tokens this authentication client and the tokens from it will only be used by our server application and not shared with anybody else. But then the other client that we define here, the public auth client, has just a single scope or single operation that we want to grant, and that's the viewables read. So this, the tokens generated by the public authentication client will be much less powerful. The tokens will only be able to view some converted file from within Forge. This token we can then send to the client because Forge Viewer will eventually need it to be able to view a model, right? But instead of sending a token that is capable of doing everything, right? We only send a token that is only able to view some conversion output from Forge. So even if for some reason somebody kidnapped our browser and wanted to steal our access token, first of all, the access token only has a limited time to live before it expires. And second, we will not be sending any token with these capabilities, with these scopes or operations. The only token that we will send to the browser for the viewer, the token will only be able to view converted files in Forge. That's why we have two authentication clients. Again, it's a recommended practice. And then we implement two helper methods, one called getInternalToken and one called getPublicToken. This is the actual process where we will ask the client to generate the actual access token. So access token is a JSON that includes the token itself, the long secret magic string, and it includes some additional fields, the JSON object, like how many seconds, I believe, before how many seconds the token is valid for before it expires, right? And what type of token it is. So we simply, so these two methods look very similar. Then they do the same thing, just with different clients. So this getInternalToken method will be using the internal authentication client, generating tokens just for internal use. So these tokens we will only use inside our server application. We will not send the tokens to the browser at all. And the other one, getPublicToken, this one will generate new tokens using the public authentication client. And this is what we will eventually use. These tokens we will eventually send to the browser so that the viewer will be able to access our designs from Forge. And we export these two helper methods outside of this auth.js file. So I hope that makes sense. And now we can implement our first endpoints for our Express server application. So let me create a new folder here called routes. As I mentioned earlier, it's a good practice to store any custom JavaScript logic, Node.js logic for handling custom endpoints in your server application inside the routes folder. And I'm going to create a new file here called auth.js. Inside here, let me once again, we're looking at the server endpoints section. Copy it in the chat. Let me grab the code from here, paste it in our routes/auth.js file, and explain what it does. Here, we're importing the getPublicToken method that we implemented in our services Forge auth.js file. Right, this is the method that will generate a public access to, or an access token that only has a single granted operation, only single thing it can do, viewing objects from Forge, converted objects from Forge. So we import this helper function from our services script. And we once again import Express. That's the third-party dependency for building Express.js server applications. Now we're using another concept from the Express framework called router. Router, you can think of it as an object that can handle different types of endpoints, but you can then take this router and attach it to different paths of your server application. So for example, in this case, our router is able to handle endpoints or requests to endpoints ending with /token. And then depending on where we connect or mount this router to our application, it will actually be handling different paths ending with /token. So we create a router object with this express.router function. And then we can define as many endpoint handlers like router.post. We could use this to handle some post requests, let's say coming to /foo, right? Or we could handle patch requests to bar endpoint. Get, delete, post, patch, those are all the standard HTTP methods, right? So if you want to learn more about these, I would recommend to go to MDN, that's the Mozilla Developer Network, and search for HTTP methods. So these are the different types of methods used when making an HTTP request, right? Typically, get method is used when you want to actually retrieve some information from a server. Head means when you just want to read some like metadata information about an object without retrieving the actual object. Post is typically used to create a new type of resource or a new type of object. Put is typically used to overwrite or replace. Delete, that's clear. And then there are a couple more. So these are the typical HTTP methods. And these are the same you would find in your Express application or in your router. So the same thing I could do, I could say in our server.js file, I could say app.gets foobar, and now do something. And now this function would be called whenever somebody makes a request, a GET request to our servers /foo/bar endpoint, right? Or I could say app put, and this code would be executed whenever somebody makes a put request to our servers /foo endpoint. But again, putting all the logic into a single file is not very flexible. We want to give it a little more structure. That's why we're building this router. So now we have a router which can handle a single request, single endpoint, and that is something ending with /token. And what it'll do is it will basically use our helper function to generate a new access token with just the viewable read scope. And it will send it back to in the response as a JSON. Now this REST and REQ and REST objects are request and response objects from Express, from the Express.js framework. And by calling something like res.json, we basically say, if somebody makes a request to this endpoint, simply respond with a JSON that's some kind of object that I pass in as an argument. I could also say res status something 404 end, which means I could say, well, respond with a 404 code, meaning not found, and end the response. Right? This is something I could say to respond, to inform the user that something went wrong, that they're maybe asking for a resource that does not exist. But what I'm going to use is the res.json to actually send a JSON response back. So by calling res.json, the Express framework will actually put together an HTTP response with the proper content type and content length and everything. And I'm going to pass in the JSON object with the actual access token. So that is what we will receive in the response from this call. Now, if I kept it as it is, the server would actually not this code would never be called, because I have a router, that's true, but the router needs to be attached to our application. It can be attached to multiple places in our app, which is the advantage of the routers, right? But now it's not connected anywhere. So what we'll need to do is we need to go back to our server application. We will need to say app.use and something. And I believe the right endpoint, just let me check. It's API/auth, yes. Auth require routes auth.js. So what this line means is we're basically saying we want to attach a router that we import from routes auth.js file, and we want to attach it to this particular path. So now what that means is that every time somebody makes a request to our server application, starting with /API/auth, the actual response will be handled by this router. So if I make a request to /API/auth/token, the Express server application will jump into the router, and it will find a token endpoint there. So this code is actually going to be executed whenever somebody makes a request to /API/auth/token. So I hope that makes sense. So this is not the complete endpoint. This is just a suffix that this code will be able to respond to. And now the magic of routers is that we could also mount the same router to another prefix. So if I do this, now we have the same router that's actually going to be able to respond to requests to different URLs, right? So then this code will be called for both get request to token, right? And this code will also be called for requests to foobar token, because we took this router and we mounted it in two places of our Express application. So that's why the routes are an interesting idea, because again, oftentimes you may have some kind of logic that you want to use for different types of and different groups of endpoints. Of course, for now, we're just going to keep it as API auth. And that way, that basically means that this code will be executed whenever somebody makes a GET request to /API/auth/token. And eventually, this is the endpoint we will use to get the token for our viewer in the final step of our tutorial today. All right, that's for our authentication steps. And now we can try it out. So let me double check that I have everything set here. I have my router mounted to the proper prefix. That's correct. I have my helper methods, helper functions, get internal token, get public token in the services/fork/auth.js file. That is looking good. So we can try and run our application. So I'm going to, again, run it from within Visual Studio Code to make sure that the environment variables are passed to it. Okay. So let me run the app and switch to debug console. All right, so our application is running, listening on port 8080. We can try now. If I go to localhost 8080, I will still get the cannot get / because we still haven't implemented any logic that could respond to a request that is just the name of the server / and nothing else. All right, so but what if instead I'd say /API/auth/token? There we go. So now we actually requested an endpoint that our server knows how to answer, right? It's the API/auth/token handled by our router. And what it does, if you remember, the router will simply request new access token and send it back in a JSON format. We can try and put a breakpoint here just to explain how that works. By the way, if you only see like a black and white text and not this formatted one, that's okay, don't you worry. This is just a Chrome extension, because I think you can get a JSON formatter, I think. This is just a Chrome extension that will detect JSON file being open in the browser. And if it does detect one, it will actually parse it, give it some color highlighting, and actually make it collapsible, and so that you can collapse and expand nested structures if it's a more complicated JSON object. So you can see that now we actually got a JSON object back from our server, returning the actual token. This is the string that I can now use to communicate with Forge. But of course, this one, it has hidden inside it embedded information that this token is only allowed to request the conversion views from Forge, right? It cannot create data, it cannot modify or delete any data. This token is only allowed to view conversion outputs from Forge. And here we see that what type of token it is. And now here we see that it's valid for 3,600 seconds, so 1 hour. And we also see when it will expire. So now we have our first server endpoint that is working, right? I mean, it's not doing much. It's just returning some sort of a token, but it's a good check to make sure that your application is working as expected so far. All right, and now if we try it one more time, just to see that I put my breakpoints in the route/auth.js file. API auth/token. Oh, I stopped the app. No, am I running? Stop. We'll run the app one more time. Oh, I'm using the wrong port. So it's on port 8080. And I request /API/auth/token. And now you can see the VS Code intercepted the code and stopped it at this breakpoint line. So now I can inspect, for example, the objects, right? The parameters or a function. So I can see that, okay, our REQ, that's the request object, will contain information about, okay, what's the base URL, right? So now we're /API/auth/token. Maybe if there are any parameters in the request, we would see it here. If the request had any content in its body, we would be able to see it here. But at this point, it's just a simple API/auth/token request. So what we can do, we can step inside the get public token. We check if it's authorized, meaning that if it does have any token that's valid, and it does not. So we actually call this public authentication client authenticate method. And again, just to drive the point home, what this is really doing, let me open the official documentation on the Forge developer portal. If I look at authentication, there is a single endpoint in the two-legged context in the Forge authentication service. And that's this one, /authentication/v1/authenticate. And what this does is it gets a two-legged access token when you provide your application's client ID and client secret. So this is what it expects in the body of the request, right? And it expects a body in the content type X www form URL encoded, right? This is all the intricacies of building your own HTTP requests by hand. So you would need to set the proper content type that Forge actually expects. And you would need to structure the body, include all these properties in the body by following this encoding. And then you would need to check the status code of the HTTP response, because if you get, I don't know, 415, that would indicate that there is some problem with the content type, that you provided a wrong content type. Or if you got an error saying 429, that would indicate that you hit some request threshold where you can only make some certain number of requests per minute, for example. So all this is handled for you. And then, of course, in the response, you get some sort of data. So all this is handled for you by the authenticate method, right? So this authenticate method will, under the hood, it will put together the HTTP request with the proper content type and encoding. It will handle the response codes in the right way, right? And it will send you the result if needed. So that's what we do here, right? We call authenticate. So the token will actually be stored inside the authentication client. And then when we call authentication client .get credentials, this will actually return the latest retrieved access token. And this value we then send in the response object JSON method. So we send our token back to the client who made this request as a JSON, as in a JSON format. All right. Let me stop the app and ask, is everybody up to speed? Everybody doing well? Everybody following along? Or has anybody gotten stuck on anything, any step so far? Okay. So now it looks like everybody's all set, which is great. I'm happy to hear that. So now I would say let's start our polling again. Can I relaunch? Yeah, I can relaunch the poll. So I started the poll again. Please let me know if you what you want to do next. If you want to take a break or continue straight away with the next step, which would be implementing the endpoints in our server application that would be used to upload files to our Forge application and read the contents of a Forge app, of a bucket. All right, so let's see. So for now, it looks like people would prefer a 15-minute break. So let's see if that changes. All right. So majority voted for 15-minute break. So I hope that's all right with the rest of you. So let's take 15 minutes. Let me stop the poll. And now it's 12:48 on my end. So 15 minutes from now, we'll get back and we'll move to the next section. That's going to be the uploading and translating of our designs in our application. All right, so I'll see you here in 15 minutes. And we're recording. Perfect. All right, so we're moving on to the next segment of our tutorial, upload and translate. This is where we will implement the server-side logic for our application that will help us, first of all, list designs that we've already uploaded to our Forge bucket. And then that will also help us upload new designs from our client web application. And we'll also make sure that the designs that we upload to Forge we will automatically trigger their translation. So before we start coding, let me just explain a couple of things, what these mean. First of all, what a bucket is. So one of the services in Forge is called the Forge Data Management Service. And that is the service responsible for, well, managing your data. We can take a look at it in the documentation. I go back to the documentation section of the Forge developer portal, and I can see the data management service here. In the API reference, you'll see a bunch of categories. The one we'll be working with now, it's called OSS. That's the Object Simple Storage. You can see that it has this concept of buckets and objects. Buckets are very simply put, sort of like top-level folders that you can create and manage, and that you can use to store and organize your files, your designs in Forge. They're very similar to buckets in Amazon's S3 service, if you've used that one before. So you cannot really have you cannot have nested subfolders or folder structures. This is just a top level. So you create a bucket. And again, don't forget, the bucket name must be globally unique. And then you can use your buckets to store designs for maybe different Forge applications that you're building, or you can create a different bucket per customer, for example. It's up to you. Just the only requirement is for the buckets to be globally unique. And then objects are the actual designs or data that you're uploading and downloading from buckets. And again, if you look at the post bucket, and as I was saying earlier, you can see that this is a post method. That means that one is typically used in HTTP requests when creating something. So post buckets would be an endpoint that you would call in the Forge data management service if you wanted to create a new bucket. This is the endpoint you would call. Now, there are some requirements, as we mentioned earlier, for the bucket key, right? Or in other words, the name of the bucket. It has to be globally unique, and it must only contain certain characters, right? So only lowercase, alphabet, and numbers, and underscores, dashes, and dots. That's the only thing you can use in the bucket name. And of course, if you happen to choose a name that already exists, you get a 409 response conflict saying that the specified bucket name or key already exists, just so you know. And then you have some additional endpoints in the data management service that you can call, for example, get buckets to get a list of all buckets, or get objects, for example, to get a list of all objects in a specific bucket. So this is the endpoint that we'll be calling, but we will not be calling it directly. We will actually be using the Forge SDK class and method to get this list of objects in the next segment. Now, yeah, okay, let's get to that. And then we can take a look at the Forge extension inside Visual Studio Code one more time. All right, let's go back to our tutorial, or actually VS Code first. Let me stop these. We will create one more file under the services/Forge subfolder. So here we have in the auth.js file, we have our helper functions for managing authentication with Forge. We're going to create one more file here called oss.js. And here's where we will implement our code for interacting with the Forge data management service when listing, files in a bucket, uploading new file. So what I'm going to do now, go back to the tutorial. And now we're looking at the data and derivatives section. Let me paste the link in the chat. All right. And here's the content of the oss.js file. There's a little bit more in there. So let me just copy it and again, explain what it's doing. I'm going to paste the code inside the services/Forge/oss.js file. And what this means is, what this is doing, we're grabbing one of the built-in Node.js modules. So this is not a third-party dependency that we installed. This is, the FS is actually a built-in native module available to Node.js, to all Node.js applications. The FS stands for file system. So it contains, it's an object that contains methods and classes to work with file system. Then once again, we are importing some classes, a couple of classes from the official Node.js Forge SDK, in this case, Buckets API and Objects API. So these two classes we will use to access some of the buckets endpoints, like the one for creating a new bucket. And the objects API we will use to access some of the objects endpoints in the Forge data management service, such as listing objects in a specific bucket or uploading objects to a specific bucket. All right, and then we implement 3 helper methods. Now, the first one might be a bit confusing. Ensure bucket exists. Basically, we want our application to be smart, and if somebody runs the application with a bucket that does not exist yet, we want to make sure that the application won't crash. So that's why we've implemented this helper function called ensure bucket exists. And what it does, when you take a look, it simply uses the buckets API class from the Forge SDK to retrieve details of a specific bucket with some name. And then the whole thing is wrapped inside a try catch, and we check if the response fails because of 404, bucket not found. If this happens, this means it's a good thing because this bucket does not exist yet. And that means that we can actually create it, right? So at that point, we instantiate the same buckets client, and we call this create bucket, which under the hood will make the post request to the Forge data management service asking for this bucket to be created. And just like with the HTTP request, the endpoint takes a couple of arguments, of course, the name of the bucket, and also a data retention policy. And again, you can read more on that in the documentation. Let's see, where are we? Policy key. Here, this explains that this parameter is required, and it specifies the data retention policy, meaning how long you want your data to be stored in this specific bucket. You can choose from 3 options. Persistent means once you upload data or files or objects to this bucket, the data will remain there until you manually delete it. If you set it to temporary, I believe that means that the data will be automatically cleared after 30 days. And transient means that the data will be automatically removed after 24 hours. I believe that's how the times are. We can check actually here. We look at the data retention policy. So transient means data will be automatically cleared after 24 hours. Temporary means objects that reached 30 days of age will be deleted, and persistent means that the data will stay there until you unless you decide to remove it. Now, this might be helpful in different situations where maybe you only need to upload your designs to Forge to have them translated, but then you don't want to store the original design data anymore. In that case, you can set the data retention policy for your bucket to be transient. Because as soon as you initiate the conversion process and you extract data for viewing out of your original design, you don't actually need the original design. So if you set your buckets to the data retention policy transient, that means that the buckets will automatically clear objects or files that are older than 24 hours. All right. This is up to you. You can decide which data retention policy you want, but for the bucket that we'll be creating for our application, we're going to set the policy key to temporary. So that's the 30 days. So after any objects you upload to this bucket, when they reach 30 days of age, they will be automatically removed. And of course, as we mentioned earlier, right, we will not be able to make this request to Forge unless we can authenticate ourselves, unless our application can authenticate itself. That is why we're once again using this get internal token helper function that we implemented earlier, right? Remember, this helper function will generate an access token that has more capabilities. That's the internal one, the more powerful one. This one has scopes such as bucket create, data read, data write. And it's the bucket create scope which, by the way, you can also see in the documentation. If I go back to the documentation for the post buckets endpoint in the Forge data management service, you'll see that this endpoint requires a scope bucket create. And luckily, that's one of the scopes that we included in our helper method that generates the access token, right? If we didn't include this bucket colon create scope when creating our access token, Forge would actually respond with 401 unauthorized, saying that you're trying to request an operation that your access token is not authorized to do. All right. So this is basically all the ensure bucket exists helper function is doing. It checks whether a specific bucket name exists, and if it does not, it will try and create it. But if the request fails with any other error other than 404, maybe the request fails with 401 unauthorized, then it will throw the error so that this will actually make the application fail, saying, oh, by the way, you're trying to get information about a bucket that your application does not own, that this bucket is already, it exists, and it's owned by somebody else. So we will not handle that case in any special way. We will simply rethrow the error. And then finally, the two helper functions that we will be exporting from our OSS JavaScript file are list objects and upload object. So as the names hopefully indicate, list objects will first make sure that the bucket that we want to work with exists and that we have access to it. And by the way, the Forge bucket we import from our config.js file. So this line will make sure that the bucket is actually created, that we have access to it. And then we instantiate the objects API class from the Forge SDK, and we call get objects. And that way we get a list of objects from a specific bucket from our application's configured Forge bucket. Now, if you look at the documentation for the listing of objects from a bucket in the Forge data management service, you'll see that it actually paginates the results. It doesn't return all the files at once. It returns them in pages of some pre-configured size. You can choose that size. I think the limit number must be under 100. So you cannot configure it to have pages longer than 100 objects. So in this case, we just say 64. So we will ask the Forge data management service to give us the first 64 objects in our bucket, or up to 64. And again, we provide the internal token. Otherwise, Forge will refuse to give us this information if we don't authorize ourselves or authenticate ourselves. All right, and we grab the objects from the response. But if we just stop here and return the list, we will just return up to the 64 objects from our bucket, even though there might be more, right? So to do things the right way, we actually include a while loop, which will check, it will keep requesting additional pages as long as there is a next parameter in the response. So as long as there is a next parameter in the response coming back from Forge, that means that there are still some more pages to request. So in that case, what we do is we extract the start at parameter. That's like a cursor. If you're paginating through data in the Forge data management service, you can specify the limits, of course, how many objects you want to retrieve, max. And you can also specify the starting point, like the starting object to retrieve those up to 64 objects from. So originally, when we make the request, we only specify the limit, so that will give us the first up to 64 objects. But then later on, as long as there is a next parameter in the response, we will basically keep paging through the additional pages. And we will keep adding these additional pages to the list of objects that we ultimately return. And for uploading, again, we at the beginning, we just make sure that the bucket that we want to work with actually exists and that we have access to it. And then what we do is we use the built-in FS module, the file system module from Node.js, to read a file from a specific path. The path is coming as an argument to our helper function. We read it into an in-memory buffer. And then we call another method from the Forge SDK called upload resources. This is used to upload files to Forge, right? Again, we specify the bucket where we want to upload the design to, and then we specify one or more files that we actually want to upload in this call. So here we just have a single one. We specify the name of the object, how it should appear in the bucket, and we specify the data, that's our memory buffer that we read from file system. And then there are some additional parameters for the upload process that you can configure. For example, the use acceleration would mean that you could upload the file in the object in chunks in parallel. And you can also control how long you want to wait for the upload before eventually timing out if it takes too long. If it takes, so in this case, if the upload takes 15 minutes, that means that there's potentially something wrong. And in that case, we will time out and this call will fail and throw an exception, a timeout. Now, important note to make here, in older tutorials, you might have seen a different method being called. Instead of upload resources, you would see something like upload object. That method, older method, is being deprecated. And this one, the upload resources, is the new recommended one, because under the hood, this upload resources method actually uses a new, more efficient upload process, where instead of the data being sent to Forge and then to some storage system, here the data is actually stored directly to the storage system. If you want to read more about that, I would recommend that you Google for Autodesk Forge Direct S3. Let me try this one and copy the link in the chat. So this is the new process of uploading data to Forge in a more efficient way. And that's exactly what the new upload resources method is doing. So this one is using the new efficient way of uploading data directly to the storage, which in this case is Amazon's S3. All right. And then depending on if the result contains an error field, Boolean set to true, that means that, and we're checking the first of the results, right? Because if you're uploading multiple files, you will get the same corresponding array of results. We only upload a single file, so we only check the first of the results. We check if there is any error, and if so, we throw an exception with the body of the response. Otherwise, we just return the response as a success. Let me check the Q&A. Related to bucket, in a simple viewer, if we have 3 clients for 3 different designs to view, one client design should be visible to other client. How to do that? Not sure I understand the question. So typically, again, like having a bucket is a simple way to organize data per application. So the most common way is to create a bucket for your application, where your single application will be managing all its data, right? Then your server application itself can decide what subset of the objects in the bucket it will actually show to the client, right? So think of it this way. You can have an application. You're building a Forge application. Let's call it My Fancy Design Preview, right? You can create a single bucket for this My Fancy Design Preview app where your application will store all of its designs. But then your application can actually do some filtering, and maybe the application will ask your users for some login, or like maybe the application will ask the users to log in with, I don't know, their GitHub account. And then you can keep a database somewhere in your server application that will map the individual objects in your bucket to a specific user, right? So when that user, maybe you will only want to show the designs that were actually uploaded by that particular user. So based on some user ID, you can do some filtering and only show the files that the user is actually expected to see. So this is the most common way to have a single bucket per application. There might be some use cases where maybe you want to do it differently, where you can have a single Forge application actually manage multiple buckets storing data for maybe different tenants or maybe different customers, but that's not that common. It's up to you, right? It's really just a silo, so that when your Forge app owns a bucket, no other application will be able to access that bucket. Even if you have, let's say, under your Forge account, you have 5 Forge applications with different client ID, client secrets, right? And if one of your applications owns a bucket, only this application will be able to see it and access it. None of the other applications, whether they're yours or somebody else, some other developers, they won't see and they won't be able to access the bucket. And if you have, like, okay, so a client 1 is for application 1 and client 2 is for application 2. If you have, again, like separate applications, you can have completely separate buckets for them as well, if that works for you, if that makes sense for your type of use case. Right? Again, once you have one Forge application creating or owning a bucket, no other application will be able to access it. Well, actually, that's not entirely true, because that's a more advanced use case, but let me just explain that this is actually possible. When creating a bucket, you can actually specify this additional parameter in the payload, the access enumeration, for a specific auth ID. Let me see if there is an example. It already exists. So there is not an example for that, but basically, instead of this simple payload where you just specify the name of the bucket and the data retention policy, you could also have an allow list. Let me check. Here, allow is an array. So you could have an array of objects specifying other client IDs that you want to grant access to this bucket. And then you can, for each auth ID or Forge client ID, you could also specify the level of access, full or read. Right, so there's an advanced scenario where you can actually configure a single bucket to be accessible by multiple applications. So I apologize. I didn't want to mention this advanced scenario first, but I think it probably does make sense. So by default, a bucket will only be accessible by the application that created it. But in this advanced scenario, you can actually share the data in a bucket with another application with a different Forge client ID. So that you can do as well. If again, it really depends on the use case, right? Like I said earlier, the most common one is each Forge application using its own bucket to manage its own data, its own set of data. All right. So that is for our helper methods for listing objects and uploading objects to the Forge data management service, to a bucket. Next thing we'll do is, we go back to a tutorial. We will add some helper methods for the model derivative service, derivatives. And again, just to stop here a little bit, explain what this means. Model derivative service is another Forge service. And this one is responsible for extracting information out of your design. And what we mean by the information, it's things like thumbnails, 3D views with all the 3D geometry, 2D drawings, scene hierarchies, or any like custom, logical hierarchies that might be defined in your design. And more importantly, and really the most important part, that's the information that's extracted from your designs by the model derivative service, is the metadata, right? So in your design files, you might have different types of information properties and metadata defined on the individual design elements. All this data is extracted from your designs by the Forge model derivative service. It can ingest over 60 different file formats today, not just Autodesk file formats, but even our competitors. So if you have an IFC, a DGN file, or SolidWorks file, for example, you can upload these to Forge and use the Forge model derivative service to extract information out of these. One more question. All right, so a correction on the earlier question. One client design should not be visible to the other clients. How to do that? Yes, so that's basically boiling down to a general topic that's called ACM. That's not specific to Forge. This is like when developing any kind of application, sooner or later you run into something called ACM, which is access control management, which is basically a way for your application to decide which user gets to see what data, right? And this is entirely up to you. You're free to implement ACM in any way you want, right? So of course, your application will somehow need to ask its users to authenticate themselves, right? So you can either ask your users to log in with their Google credentials, so you can use Google authentication mechanism, or you can use the users to, maybe you already have some online service where your users have their accounts. Then you could, ask them to log in with that service. And then based on the user ID, when the user has logged in successfully and when the user authenticated themselves properly, you can have your custom access control management, where you can have a database with information stored as to, like, this user can access these designs and this user can access these designs, right? And then it's up to your application, because the user will always log in, and the web application that you'll build will always ask your server to get the list of objects, of designs, right? The web page will never go directly to Forge to get the list of designs in a bucket. It will always talk to your custom server first. So that is where you can implement your access control management, and in any custom way you want. Right, so typically this would be some sort of a database storing information about what users are registered in your system and what files they have access to in your bucket. So then when somebody sends a request to our server to list objects, this method would be more complex, right? Because here maybe we would need to accept something like a user ID, and then inside here, when we would not return all the objects in our bucket, but we would actually filter them based on some database with the access control data. So we would filter only the objects that this particular user with this particular user ID is allowed to see. So there is no like a ready-to-use solution provided by Forge. This is left up to whoever is implementing the server application to implement their own access control management system. So I hope that answers the question. Oh, and by the way, tomorrow, when looking at the three-legged authentication system, that's something where actually the ACM, the access control management, is in place, because tomorrow we will be building an application where we will not be uploading files manually, but we will be accessing our users' files in, let's say, Fusion Teams or BIM 360 or Autodesk Construction Cloud. So those are products, Autodesk products that have been built on top of Forge. And those products implement their own access control management system, right? So if you are a user of a BIM 360 project, or if you're a user of a Fusion Teams project or Autodesk Construction Cloud, you already have access to certain files, and somebody else can share their designs with you, so you will also see them in the product. That's handled through the access control management implemented by the individual products. And tomorrow we'll be building an application where you will be able to log in with the same credentials that you would use to log into that BIM 360 or ACC project, and you will actually only see the data, the designs from BIM 360 or ACC that you are allowed to see. So you get the access control management functionality for free. So that's something we'll cover tomorrow in the Hubs browser tutorial. All right. So the next piece is, again, for the model derivative helpers, right? So we want to implement a helper function that we'll be able to use in our application to trigger the conversion, the extraction of data from our models. So let me, so now we're at the derivatives section. Let me put it in, copy it, chat, so we're all on the same page. So let me once again copy this code and explain what it does. So this is under the services folder, Forge subfolder, md.js as a model derivative. md.js. All right, what this code is doing, again, we're bringing in one of the classes from the Forge SDK, derivatives API. This is the one that will be used to communicate with the Forge model derivative service. And once again, we're bringing in the helper function for generating internal access token. And we provide three functions, one called translate object. This is what will actually initiate the translation process of the design that you've uploaded. Because one thing to keep in mind is that the translation will not happen automatically after you upload some kind of design into a bucket. When you upload the file just sits there, but Forge will not do anything automatically. If you want to start the conversion process for the model derivative service to extract information out of this file, you'll need to trigger a conversion job or translation job. And that's exactly what this helper function will do. We define some payload for the request, and then we call this, we instantiate the derivatives API class, and we call the method called translate, right? That will, again, to drive the point home. The translate method, if I go to the model derivative service in the documentation on the dev portal, start translation job, right? So the translate method will actually send a request to this endpoint, and that will start the translation process, so that the results of the conversion can later be loaded into the viewer. That's really because we need to wait for this, right, before we can preview the design in the viewer. All right, the second helper function, get manifest, is something we're going to use later to find out whether this file is already available or whether it's already been translated, because the get manifest method of the derivatives API class will retrieve a JSON describing the output of what was extracted from your design. So if there's no manifest available, that means that the translation has not happened yet. So we simply try and call get manifest method on the model derivative service to retrieve the JSON with the information about what was extracted from our design, from a specific design, identified by its unique URN. And if we get 404, we return null, saying, okay, there is no manifest for this object just yet because it hasn't been, the translation job hasn't been initiated for this object. And finally, we have a helper function here we call earnify. There is a one little gotcha when working with object IDs that you want to translate. The problem is the object ID, or the ID of whatever object you want to translate, will be used in the URL. Like here, for example, right? When we want to request the manifest of a specific object, we will need to include the ID of that object in the path, in the URL. But the ID of the object may actually contain some strange characters like slashes or colons, or some characters that could mess up the URL. Because if you imagine, if you want to make this request and the object ID would include some slashes, it could actually confuse the server because it would not understand what exactly we're looking for. That's why the object IDs, the IDs of the objects that we want to query or ask about in the model derivative service, they need to be encoded into safe characters that can be used in the URL without breaking it. And that's why we call this thing called URN, which is basically the original object ID, but encoded using base 64 encoding to make it safe for use in URLs. And so what we do in our helper function, we get the original object ID, which is a string that can have some weird characters, slashes, backslashes, colons, and we encode it into the base 64 encoding, which means this is a special encoding that only uses the 64 ASCII characters like the lowercase, uppercase, alphabet, and numbers to encode and potentially unsafe string. And we return the base 64 letters that the base 64 encoded ID. All right. Let's see if I can switch to, yeah. So those are the helper functions for the model derivative service for the translation of our files. And finally, again, what we'll do is we'll make this new functionality available in our server application through another set of endpoints, right? Just like today, up till now, we've only implemented the /API/auth/token. So now we'll add more additional endpoints that will be used for getting a list of objects, uploading object, and translating it. All right. So now what I ask you to do is go back to the routes folder. This is where we define the different express routers and create a new file called models.js. And in here, we'll once again create a router that will handle a bunch of endpoints. Let me grab these from here, from server endpoints. And paste it in our models.js file. So again, what we're doing here, we're importing the third-party dependency Express.js framework. Now we're also importing Formidable. That's the other dependency that we installed, if you remember, right? Express Formidable is a third-party module that will help us help our server accept file uploads using this custom special multi-part form data encoding. And we bring in the helper methods from our OSS.js file, right? These are the helper methods for listing all objects in a specific bucket and uploading an object to a specific bucket. And then we also bring in the helpers for the model derivative service. That's the helpers for translating an object or starting a translation of an object, getting the derivative manifest that way finding whether there is something to load into the viewer. And the earnify helper function that takes an object ID that can contain unsafe characters, and it will base64 encode it so that it can be used in URLs. All right, and in this router, we specify 3 endpoints that it can handle. First of all, it will be able to handle GET requests to just /endpoint. And again, be careful, that will depend on the actual URL, will depend on where we mount or connect the router to. I can tell you already that in the next step, we will mount this router to our application to the /API/models path. So basically, this code will be executed for any requests, GET requests to API/models, or like this. Right, so when somebody makes a request, GET API models request to our application, the Express server app will execute this code and respond accordingly. And what it'll do is, it'll call our helper function to get the list of all objects in a specific bucket. And it will map the array of results, where it will, for each object, it will return a JSON object that will contain a name, that's the original name of the file in the bucket, and a property called URN, where we will take the original object ID, and I'll show you later what this object ID looks like, and we will earnify it. That's the base64 encoding, right? Turning it into a safe string that can be used in the in the URLs. So we simply get a list of all objects in a bucket, and we transform the array into an array of JSON objects containing a name and URN, where the name is something we want to display that's like a display name or a label for each design, and the URN is the base64 encoded object ID that we will later use, for example, when loading the design into the viewer. All right, next one is a GET request to a status of URN/status. And this is the first time you can actually see this special syntax with a colon. This will be used to handle all requests to /API/models/URN/status. And the colon means that this is actually a variable. This is not a hard-coded path. This is going to be something dynamic, where this part between the slashes can be anything, right? And we will retrieve the actual value that the server application received in the path through the request object. Here you can see when we say req.params.url. This is basically saying, you know, grab the actual value of the path from this URN section and pass it as a value to our helper get manifest function, right? I could call this whatever I want. I could call this URN foobar, right? And then I would just have to the URN foobar when grabbing the value from the request parameters. I'm just going to keep it to URN. So what we do when somebody makes a request to /API/models/URN/status, we use our helper function to get the manifest for this URN. If it exists, and this is more involved. We basically go through the JSON to try and find if it does have, if it's complete, basically, if it's ready, or if there are any errors. Because the JSON can be more complex. Again, you can find the structure of the manifest JSON in the documentation on the Forge dev portal, right? So what we do here, we basically go through all derivatives inside the manifest, because when translating a single design file, Forge can actually generate multiple outputs. For example, when translating a Revit file, each 3D view and each 2D sheet inside a Revit file can actually end up being a separate derivative, right? So there is one-to-many mapping. These are called derivatives. So what we do in our code, we actually iterate through all the derivatives all the possible 3D views and 2D sheets extracted from a Revit file, for example. And we try and check if there are any messages. These could be warnings or error messages that were added to the manifest by the extraction process. And then what we do is we respond to this request with a JSON containing the status of the translation, whether it's in progress or failed or succeeded. If it's in progress, we can also provide some indication of how far along the process is. And finally, the messages, if there are any errors or warnings. So we send a custom JSON object in response with these 3 properties: status, progress, and messages. Otherwise, if manifest is not available, we return status not available. This is like a custom way for us to tell the viewer or to tell the web page, hey, by the way, we don't have any information about this manifest, which means that the translation probably hasn't started yet for it. So that's our logic for handling the API models URL and status requests. And finally, you can see now we're not using get anymore. We are saying router.post. So this code actually handles post requests to API models, or like this. Okay. And when somebody makes a post request to this endpoint in our application, there is one important thing to notice: formidable. So instead of the usual name of the endpoint and then followed immediately by the code that should be executed when the request comes to this URL, we actually insert something before implementing our custom function. This is once again the concept of express middleware. This function basically says whenever there is a post request coming to API models, before doing anything else, run the request through some other function that may or may not react and process the request in a certain way. And what the formidable, that's the Express Formidable third-party plugin that we're importing. What this will do is it will take a look at every incoming request, every incoming post request to /API/models. It will try and see if the request is actually trying to upload some file. So internally, this formidable middleware, it will check if the incoming content type is multi-part form data, if the payload actually contains some kind of a file. And if it does, it will enrich the request object with some additional data. And you can see that already here at the next line. We're calling req.files. So this files property is typically not available on a request object, but when the incoming request is processed by this middleware, the middleware will actually parse the data from the incoming request and make the files or whatever is coming to us, make it available under the rec.files dictionary. So what we do here, because we don't need to worry about checking the content type and parsing the input, parsing the payload of the incoming request, because the formidable middleware has done it for us already. Then we can simply just grab, because we know that we're expecting that one of the files being uploaded to this in this post request will be called model file. So we know that we can already grab a reference to this uploaded file thanks to the formidable middleware. And we can check if the file does not exist, we just respond immediately with 400 HTTP code saying, you know, we are missing a file that we were expecting. Otherwise, we call our helper function upload object to upload, providing in the name of the file that was uploaded from the web application, as well as a path to some temporary storage where the formidable middleware temporarily stored the uploaded file on the server, right? So this will be a temporary path to some location on the server's file system where this uploaded file is now waiting, and we can grab it and upload it to Forge. And as soon as that is done, we also immediately trigger the translation of the object, right? So here we could just return immediately, not do anything else, but to save some time and make it, make the user experience a little better, as soon as the object is uploaded to Forge, we immediately initiate a translation of this design by the model derivative service. So by that, we grab the original object ID, which again may contain unsafe characters, and we run it through the earnify function to base64 encode it, make it safe. And we respond with a JSON, again containing the name of the object that was uploaded and the base64 encoded ID that the web application can later use to load a specific design into the viewer. So this was a bit more complex. I hope you've been able to follow along the logic of the models router. Now, again, the last thing we want to do is actually mount this router to our server application. So what that means is I'm just going to say app.use. This time I'm going to say API models. And I'm going to import the models router. So this basically means that all the endpoints handled by the router will be actually prefixed by /API/models, right? So get requests to API/models will be handled by this function, and get requests to API/models/URN/status will be handled by this code. All right. So now let's see. Let's try and run our application. It's ready, listening on port 88. Now we still cannot get anything for the index page because we haven't implemented any endpoint. That's just slash. But we should now be able to say /API/models. And let me put a breakpoint in the code that should handle this request. All right, with our breakpoint, so we can step inside the code and see. First of all, we check that a bucket, which in this case, see, because I haven't configured any specific bucket name, we by default use my Forge applications client ID followed by basic app. We try and see if it exists, and if not, we'll try and create it. So we first try and call get bucket details for this bucket key. And there's been an error 404, meaning that this bucket does not exist yet, which is good news because then we can create it. All right. Now our bucket exists, and we can call the get objects method from the Forge SDKs to get the list of all objects inside our bucket. But of course, since we have just created the bucket, there's not going to be any data. The status code is 200. That means, okay, success. But the body says items is an empty array. So we just return an empty list. And what we should see in the browser, the response is just an empty list. Now, eventually, we will fix this by implementing a web application where we're going to be able to upload objects and initiate its translation. But I think this is a good time to actually go back to the Forge extension in Visual Studio Code. Because what we can do there, let me stop the application. So remember, I still have my Forge extension in Visual Studio Code configured. If I go to settings, search for Forge. I can see that I already have my application with the client ID and client secret that I created today configured. So what I can do is I can go to my Forge extension, Forge extension sidebar here, and you can see that it actually already sees my bucket, right? Because I created it a moment ago, or my Node.js application created the bucket in the helper function that's called ensure bucket exists. So I could even create additional buckets here, or I can explore this one, right? If I try and open it, there's nothing in it yet. Again, in the last section of our tutorial today, we will implement the front end, the web UI that will allow us to upload files as well. But we can even try, even now already, we can right click the bucket and say, upload object. When we do that, we will basically be asked to choose some design file that we want to upload. Maybe let me try. Maybe I'll grab one of the official Revit sample files, right? So that's the basic sample project. So I'll hit open. And now the extension is asking me how I'd like to call the file when it's uploaded to Forge. I can leave it to the default, or I can maybe modify the name if I want to. So maybe I want to add underscores. That's it. And now my file is being uploaded to Forge, right? So again, under the hood, this Visual Studio Code extension is using the same Forge SDKs that we're using in our Node.js application, right? And this Forge SDK is being used to upload this Revit file to this Forge bucket. It's also using a resumable upload, so that if my internet connection dropped, or if I decided to cancel the upload, I could actually upload the same file later, and it would resume where it left off. So let's wait for the upload to finish. And I'll ignore this pop-up for now, but let's take a look. So you can see now that we can already see the Revit file with the new name that I gave it in our bucket. And if I can even drill deeper and try and expand this file and see if there are any outputs from it. And it'll say that there are no derivatives yet because we haven't started any translation job yet. You can do that from here as well. You can right-click the uploaded object and say there are a bunch of options. For example, you can ask for object details. This will basically get the same, make the same request as the Forge SDK would, to retrieve information about this particular object in the Forge data management service. So you get information about the object ID. This is the object ID I was talking about earlier, the one that can potentially have unsafe characters, right? And information about, for example, how big the object is that is sitting in the Forge data management service. So we see that this one is 18 megabytes, for example. So let's try something. Let's right-click the object and say translate. This will make a request to the Forge model derivative service saying, hey, I have just uploaded this file to one of my buckets. Please translate it. In other words, please start extracting information out of this file, whatever type of information you can find. Thumbnails, again, logical hierarchies, 2D sheets, 3D views. All right. Did it actually? Oh yeah, translation started. For some reason, it's not. Oh, 403. Why is that? If I reload the application. Excellent objects. So for some reason, this is not working. All right, I'll need to look into this. But if we go back to our application and run it, and let's see, if we go to our localhost 8080/API/models, we should hit the breakpoint in our application again. But this time, we step over. The list of objects should not be empty anymore. And that is the case, right? Because I have already uploaded one object, that's the Revit basic sample project, to my bucket. I did not upload the file through my application's web interface because we haven't implemented it yet, but I've uploaded the file to the same bucket through the Forge Visual Studio Code extension. So you can see that the file is already there. And we have a list of a single result, and we run it through the map method, where we turn it into a list of JSON objects containing just the name and the base64 encoded object ID. So if we go back, this is basically what we would expect, right? This is the name of our object in the bucket, and this is the base64 encoded string that encodes the object ID with the unsafe URL characters. So now, of course, here you can see that this only uses alphabet letters, lowercase, uppercase, and numbers. So this one is safe to be used in URLs in the future. Okay, so this works, and this basically concludes the third segment of our tutorial, where the last one is really just implementing the viewer and the UI, the simple UI interface for listing objects in our bucket and the upload button. So I'll stop here and ask if and how everybody's doing, if everybody has been able to follow along and get their application running. When you use the /API/models request in a browser, you should at least get an empty array as the JSON response. So let me know if that's the case. If you have any problems, if something is not working, let me know. Now's the time. In the meantime, I'll inspect and investigate why my translation here is not working. And why I'm getting 403. I think I know. All right, I know why. So I'm not allowed to use this API because my Forge trial is expired. So be careful if you run into a similar problem. That might actually indicate that you have the same issue where you have an expired trial subscription. So what happened is I created this Forge application under my personal account with my personal email address. But in this case, my trial is actually expired. That's why the attempt to start a translation process actually fails. So be careful about that. Again, I'm hoping that this is not going to be your situation. Hoping that you all have basically created your trial today. So in that case, that trial subscription will be valid for 90 days, for 3 months, during which you can experiment with the different Forge APIs. So what I'm going to do moving forward is I'm actually going to delete this application because it's not really useful for me because it's linked to my expired fork subscription. And what I'm going to do is I'm actually going to log in with my Autodesk account and create a new application there. My apps. So here I'll have many more applications. So I'll create one called Bootcamp. And I will update the client ID and client secrets for both my application, that's in the .env file, as well as for my Visual Studio Code extension settings. All right, so let me update the client ID, client secrets. All right, now if I reload VS Code, oh, I'll need to run my application one more time so that it creates the corresponding bucket. /API/models. So now, okay, the application has created a new bucket for me with the new Forge client ID, but of course there are no files there. So now if I refresh, I can see that the new bucket has been created by my application. Again, using the basic app suffix, but now using a different client ID. So what I'm going to do is one more time, I'll upload an object. I'll try the same Revit file. And when the upload finishes, I'll try and translate it again. So are you guys all set? Is this all working for you? Can you let me know? Or if anybody is running into any issues, again, let me know, please. I want to make sure that you're all set for the final section of the tutorial where we will basically tie everything together and implement the web UI that will use all the different server endpoints that we've implemented. All right, so our file is uploaded. So now what I'm going to do is just going to right click it and say translate. This should not work. Yeah, and now you see that actually the hint after expanding the uploaded object says that translation is now in progress. So this may take a while depending on the size and complexity of the design. And also based on any queue that might be in Forge for this particular file format. Right, so we're at 22%. Yeah, let me stop the application in the meantime. All right, 88%. There we go. So as you can see right now, Forge was able to extract a bunch of things out of that uploaded Revit file. A couple of 2D sheets and a 3D view, a single 3D view as well. It's like the default one, I think, for this type of project. And the cool part is you can actually even right-click on these individual viewables that were extracted from the design by the model derivative service and choose what to do with those. You can see their derivative tree, properties in a JSON format, or you can even preview the derivative directly inside Visual Studio Code. When you do that, we open Forge Viewer instance right inside the editor and load that specific translation output for you. So this is already Forge Viewer component that we'll be implementing in the final step of today's tutorial. That is available right here. Let's try the 3D view. Oh, I click the viewable tree. So that's another one of the Forge model derivative endpoints that can be used to retrieve the JSON, a JSON file or a JSON object describing the logical hierarchy of that specific design. So in this case, since I used Revit, the hierarchy and the structure of the JSON will be basically, family types, families, and categories, right? So we'll have different types of floors, and we have different generic 150 millimeter floor and other types as well. So this is something you can even use to explore the logical hierarchy of your design without even loading it in the viewer, right? But we can still try and say preview derivative to once again open a Forge Viewer instance right inside the editor and load the 3D view in there. So again, eventually we will be uploading files and translating them to our application through the web interface, web application. But for now, we can even do the same thing using the Forge extension inside Visual Studio Code. All right, I don't see any questions, any comments, any problems. That's good. So now, again, question is, what do you want to do next? We have the last section of our tutorial in front of us. That's the viewer and the UI. So the question is, you want to do it now or you want to take a quick break again? So let me pull up the poll one more time. And hopefully we'll get more consistent results. I feel bad for having groups of people asking for different things. So let's see. All right. So we have the poll open. Let me know what you want to do. All right. So for now, it's looking like people would prefer a 30-minute break. Let's wait for a little bit more. Any other votes? Let us know if you want to, what you want to do next. Take a break or continue right away. Let's wait for one more minute, or let's give it a minute for people to vote. All right, 1 minute is up, and the response, a majority votes for taking a 30-minute break. Okay, thank you for your votes. And with that, let me pause the recording. All right, we're back for the final session of today's webinar, where we will tie all the logic we've built so far together, all the different endpoints we've added to our server-side application, and we will expose all this functionality from these endpoints through our user interface, through a simple web application. what we'll do is we're just going to implement the client-side logic in two separate JavaScript files, again, to keep things nice and separate. We will implement the viewer logic, so the logic to initialize Forge Viewer on our web page, to load a particular model into the viewer that we will capture and implement in the viewer.js file. Then we'll implement the application logic itself. So the logic to populate the dropdown, check what specific file actually the user wants to load into the viewer, things like that. That we'll implement in the main.js file. And all of these are client-side assets, so that we will place them under the www root folder, because if you remember from earlier, this is the folder that our Express server application is configured to serve files from. So then what that means is that when somebody makes a request to our server, let's say with an endpoint being localhost 8080/viewer.js, our Express server application will actually find this JavaScript file under the www root folder and serve it back to the client in response. All right. Let me close our testing pages and switch, and in the tutorials, switch to the viewer and UI, the final section. And again, for completeness, let me paste the link in the chat. So what we'll do is we'll implement the viewer logic in the viewer.js file. So let me copy the content of the script from the tutorials website and explain what it does. So again, we will create a new file under the www root, call it viewer.js, and paste the code from the tutorial. Now let's get over the code in this file, see what it's doing. The first comment is not necessary here. This is just a convenience utility where, as you can see in the tutorials page at the top, there is a green tip box explaining what this means. You can actually get IntelliSense for JavaScript code for the client side Forge Viewer JavaScript code, so that when you type viewer.do something, you would actually get IntelliSense based on TypeScript typings that can be installed from npm. We're not going to do that for now. You can ignore it for now, but just so you know, you can actually set up your Node.js application to even provide IntelliSense for client-side Forge Viewer APIs. Now, what we do here, we implement a bunch of functions. The first one, get access token, is actually not exported from here. The get access token function is only used for initializing the viewer. If you remember earlier when we were talking about the internal versus public access tokens, where the access token is something, the public access token is something that the viewer would eventually need in order to be able to load something from Forge. This is exactly where that public access token comes in place. If you remember, we added the first endpoint we added to our server application was this /API/auth/token, where our server is returning the public access token. And that's exactly what's happening in our get access token function. We use this fetch method, which is a built-in method in browsers, a modern JavaScript option for making requests to servers. So instead of using jQuery as one would do in the past, we can now use fetch. And what we do is we make a get request, that exact same endpoint that I just mentioned, the API/auth/token, to ask our server for a public access token. Now, if the response has failed for any reason, we throw an exception. Otherwise, we extract the access token and the expiration time from the JSON response and call a callback with these parameters. This is required because this is the way how Forge Viewer is asking you to retrieve an access token for it. So you can see that we're not actually calling this method anywhere in this code. We're only passing it to this Autodesk.viewing.initializer function. So this will initialize Forge Viewer, and it will pass in this method inside the viewer, so that whenever the viewer needs to load some design from Forge, it will call this method internally, and it will wait for you to call the callback that's passed in as a parameter with a proper access token. So this is basically a contract between you as the developer and the Forge viewer. Whenever the viewer will need an access token, it will call this get access token method, and it's up to you to provide a token to the viewer. And so now we can move to the init viewer method. This is again where we're calling the view Autodesk.viewing.initializer function. And as a second parameter, we can actually react to the moment when the viewer is initialized completely. The initialization is really just a moment for the viewer to download some additional dependencies, some additional assets that the viewer may depend on. So there are things like environment maps and background environments that may be like images that the viewer needs to download, or icons. So now calling this viewing.initializer is the way for the viewer to actually have this asynchronous moment in time when it can fetch all the additional dependencies, things that it requires. And when it's done, you can actually create a new instance of the viewer by from the Autodesk.viewing.GUI-viewer3D class. Now, pretty much all the viewer APIs, all the classes that you'll be using will be under Autodesk.viewing namespace. And GUI-viewer3D is really the main class, the entry point for the viewer APIs. This GUI-viewer3D class represents the actual viewer, the viewport that will be hosted in a specific HTML element passed in as the first parameter. So here we call it container, and this will actually be a parameter to our init viewer function. So whoever calls this init viewer function will need to provide an HTML element that will host our viewer. And then we pass in some additional configuration settings for our viewer. In this case, you can do things like, for example, configure the list of viewer extensions that should be loaded or enabled when the viewer is initialized. And finally, we call viewer start to actually initialize the runtime, the scene, the rendering setup. And we set theme to light theme 2. This is just one of the viewer APIs that can be used to control the user interface, let's say the colors of the buttons and the toolbars at the bottom. And to keep this whole thing nice and easy and easy to use with modern JavaScript, with async await, for example, we wrap the whole thing into a promise, right? Because the Autodesk.viewing.initializer is an asynchronous method, but it cannot be awaited. You need to wait for the initialization process to complete by passing in this callback function that should be called after the initialization is done. And so this is kind of harder to work with modern JavaScript code. You can easily end up in this, what they call a callback hell. So to make it a little bit easier to read, we actually wrap this whole code into a promise so that the whole, this function itself can then be awaited using the await keyword. And you don't have to have multiple nested levels of callbacks. So that's why we call resolve viewer at the end. So this will actually cause the awaited promise to be fulfilled with the actual viewer object. And finally, a load model method, helper method to actually load a specific model into the viewer. As you can see, again, here we're using we're expecting the URM. And again, URN is the base 64 encoded object ID that we want to load into the viewer. Once again, we wrap the whole thing, logic inside a promise, so that when calling the load model function in our application code, we can actually use the await keyword and have a nice, clean, linear order of function calls instead of callbacks. And what we do inside, we're using another global method, global class called Autodesk.viewing.document, and we're using the static load method on it. This method is used to load the manifests of a specific model in model derivative service. So again, if you remember, manifest, the model derivative manifest is a JSON that describes all the data that Forge was able to extract from a specific design, if any. And that's what we do here. We use the document.load method to load the manifest for a specific URN. And again, where the viewer API code in many cases is asynchronous, and it requires you to pass in some callbacks functions that should be called either in case of success or in case of a failure. So we provide two functions, one called, let's say, onDocument load success, and one called onDocument load failure. And in case of failure, we reject the promise. So the promise actually fails or throws an exception. And in case of success, we call a method on the viewer API, on the viewer object, called load document node, which is an actual method to start loading a specific derivative from your design into the viewer. At that point, we pass in the document, that's the manifest itself, but also we need to pass in a second parameter, because it's not enough to just provide a manifest. We need to tell the viewer which derivative from the manifest we want to load, because remember, a single manifest may actually contain multiple outputs, multiple derivatives. Again, going back to the example of Revit, for a single Revit file, we can have multiple 2D sheets and multiple 3D views. What we do here, we use a method on the manifest document, get root and get default geometry. This basically means get the root of our manifest, and from there, find all the derivatives that are some kind of geometry, all the derivatives that can be loaded into the viewer, right? So we're not interested in thumbnail. We're not interested in other types of derivatives. We're interested in derivatives that are actual 2D or 3D geometry. So by calling the get default geometry, we traverse the manifest, find the find the default one, the default geometry we can load, and that we actually pass to the load document node method. And this will kick off the actual loading of assets from Forge into the viewer. That is for the viewer JavaScript file. If we go back to our tutorials and we look at the application logic, so let me once again copy the code, add it to project. So we create a main.js file under www.root. And let me explain what this code is doing. First of all, you can see that we're using a modern approach to defining imports, exports between files, JavaScript files for the client side. We're using ES6 modules. That is a relatively recent thing as well, a new modern way of defining dependencies between JavaScript files. In the past, you would have to include multiple JavaScript files in script HTML tags in your HTML page, and that was kind of hard to really keep track of. So now, when using ES6 or ECMAScript 6 modules, you can actually export functions or classes or variables from one JavaScript file using the export keyword. And in another file, you can import these using the import syntax you can see here. So we're basically importing the two symbols. Again, those can be variables, functions, or classes. We're importing them from the viewer.js file. All right. And in there, we're starting by calling the init viewer, that this is our method. This is our function from the viewer.js file that initializes Forge viewer and all its dependencies, right? And it's an async event, so you can either await it or you can use the .then method on the promise that it returns. So we're basically saying initialize our viewer in a specific HTML element, and we grab an HTML element from our index HTML page by its ID. So we know it's going to be called preview. And when it's ready, we do something, right? The first line here is we're trying to check if the URL of our page where this JavaScript code is currently running, if it contains a hash. Hash is the part of the URL that you can sometimes see that starts with a hash sign. This is typically used for fragments or for anchors on the page. You can actually see that in the tutorials page, because if you go to the tutorials and let's say you click on the application logic on the right side, you'll see that the URL changes, where this hash symbol is added, followed by application logic. This is used by browsers to actually find a specific place within an HTML document and scroll down to it immediately, so that later on, if you want to share this page with someone, you can actually include this hash application logic anchor hash parameter in the URL. And then when that other person opens this URL, the page will not appear at the top, as you will see here, but the browser will actually take you directly to this application logic anchor position. In our case, we are using this hash parameter in a slightly different way. We're actually using it so that we can store in the URL the ID of the model that we want to open, that we're opening. So we take the URN by actually looking for a hash string, if there is one in the URL, and calling substring one, because the hash value, if it's available, it would actually include the hash sign. So we use substring to remove it and only store whatever string is after the hash sign. And when that's done, we call a setup model selection and setup model upload methods or functions. The setup model selection, what it does is it just takes the drop down that we will have on our HTML page and populate it with whatever objects we want to show to the user. So let's take a look at what it does. We grab a reference to our HTML element that we want to populate with our list of objects to choose from. And again, we use the fetch method to make a request to our own server. And this time we'll be making a GET request to this /API/models endpoint. This one, if you remember, returns a list of JSON objects where each object includes a name and the URN, right? These objects corresponding to designs uploaded in our Forge bucket. And if the response is successful, we basically take the HTML element, the dropdown, that's the HTML select tag, and we populate it with options, with names and values that should appear in the dropdown list, right? So we take the array of JSON objects and we run it through the map method, and we map every single JSON object into an HTML option tag, storing the URN inside the value and storing the model name in as the label of every option. And then we also set up some event handling. For example, we take the onChange, that's the change event of the dropdown that will be triggered whenever somebody changes the selection. And we react to it by calling onModelSelected. That is a function that we will have implemented later down, that we will use to ask our application to start loading the selected URN into the viewer. All right. And for model upload, setup model upload, this function will initialize a button that we will see in the header of our application, and they will be used to upload files, send files to our server application. So once again, what we do here is we grab a bunch of references to objects, the HTML elements that will be in our index.html page. There'll be an upload button, an input tag, the file input tag, actual, and the list of, and this is once again, models is the select, the drop-down HTML element with the list of our models. Now, what we do here, this is a common way of initializing file selection dialog from client-side JavaScript code. For on the button called upload, this is our HTML button, we set up a click event handler where we emulate click on our file input HTML tag. This is a bit convoluted, but hopefully it'll make sense when we get through this part. And so basically, when we click on a button, we will emulate a click on file input on the HTML page, and that will open a file selection dialog where you'll be prompted to select a file that you want to upload. And when you select that file, we will handle a change event on the file input HTML element and react to it accordingly. And what we'll do is we'll grab the file that you actually selected, that the user selected in the dialog, and we will upload this file to our server. And now coming back to, if you remember us using the Express formidable NPM package, the third-party dependency, is used to actually handle uploads with this special multi-part form data encoding. That is a special type of encoding of HTTP requests that can be used when you want to send multiple files in a single request to a server. That's exactly what we're doing here. We're creating a new instance of a form data class, which is again a native class available in JavaScript in browsers. And this one can be used to build a collection of files or values that you want to send to a server. So we keep calling the data.append, where we append a file under the code name model-file. If you remember, this is actually the word that we're going to be looking for on the server side. When using the formidable middleware, we'll be looking for a file stored under the key of model-file. And here we also include a little trick, a little improvement to the user experience. We check if the file that is being uploaded ends with .zip. And if it does, we recognize this as a special workflow where maybe the user is not uploading a single design file, like a single Revit or AutoCAD drawing, but the user is actually uploading an archive, which may potentially include multiple design files that are somehow related or referencing each other. And in that case, Forge needs to know what is the starting file inside the zip that it should start converting. And so what we do, if we detect that this really is the situation where a zip file is being uploaded, we issue a prompt dialog on the web page asking the user to enter the name of the file inside the zip archive that should be translated. And we append this information as another property to the form data object. All right. And then what we do is we make another request to our server, but this time we're making not a GET request, but a POST request to API/models. If you remember, this is where we're using the formidable middleware that is supposed to extract and parse the multi-part form data content, where we'll be sending a request that will contain at least one property called model file, which will contain the actual file that we want to send to Forge.
And it may also contain additional properties like the model zip entry point. All right, so we make a post request to our server, uploading the file and waiting for results. And if everything is okay, we should receive a JSON back, again, with the name and URN of the new object that's been created. And what we do there is we basically call the setup model selection function one more time. So after the uploading of the model finishes, we refresh the dropdown basically by calling the setup model selection one more time. And if there is an error, we show an alert to the user. And that is pretty much it. And finally, there is one piece that could be maybe a little bit easier, but we really wanted to have this application cover all of the potentially problematic states, situations. So onModel selected function is called whenever somebody changes a model, changes a selection in the dropdown. We could simply just call, load model, our function from the viewer.js file, right? To load a model into the viewer and be done with it. But we actually wanted to cover the situations where maybe you want to open a model that hasn't been translated, or maybe you want to load a model that is still being converted, right? Or maybe there's a model that you want to load that whose conversion failed. So in order to cover all these cases, we made this method more complex. So selecting a model in the dropdown will not just blindly call load model. It'll actually try and cover all the different possible situations. So what we do is we try and request the status, the manifest of our design using the /API/models URN status endpoint, right? Again, if you remember, this will simply call get manifest to retrieve the model derivative manifest for our file. And if this succeeds, if we grab the status and we check what the manifest status actually is. If it's not available, we say model hasn't been translated. If it's in progress, we let the user know that the model is still being translated, and we try and provide a percentage, the estimate of how much of the work has already been done. And we also schedule another call of this method to refresh, let's say 5 seconds later. So the set timeout is another built-in method available in JavaScript in the browsers. So by this way, we're basically scheduling the same code to be executed again in 5 seconds to check again if the translation is still in progress, or if it failed, or if it completed. If we see that the translation has failed, we show a notification saying, okay, translation failed, and we show why. We list the messages that we were able to find in the manifest. And the final case of this final switch is actually the manifest being available and valid, in which case we finally call load model. Right, so in this case, if no other cases match, meaning that the status is actually success, we can finally move to start actually loading the design into the viewer. And that's it. Here's show notification and clear notification. This is just a simple way for us to show some sort of an overlay, like a notification informing the user of a certain event. So we use the show notifications, for example, to inform the user that the model is still being translated, or that translation failed, or that the model is being uploaded. So this is for our main.js, main application logic file. Right. And let's see. We have our viewer logic in the viewer.js file and our application logic in the main.js file. Now we just need to give them an interface to work with. So we can create a simple index HTML page in our www root folder. Let me create index.html page and paste the content. So what this is, it's really just a simple HTML markup where we bring in an external dependency. This is a style sheet and JavaScript coming from developer API Autodesk.com. This is how we actually pull the viewer dependencies, right? So the viewer is always coming in a pair of files. The viewer 3d.js, that's the JavaScript code for the viewer, and style.css, which is all the style sheets for the viewer user interface. And we're also bringing in a main.css file that will be available in our www root and a main.js file that we have just implemented. The main.js file is an ES6 module that contains the application logic. And as for the markup itself, it's the body of the HTML page is quite simple. We have a div as a header that contains some kind of a logo, title, and a select element. This is the dropdown where our designs will be listed. Then we have a button called with a label upload that will be used to actually open the file selection dialog and upload a file. And then we have a file input element. This one is hidden, hidden by default, but it will be triggered when we click on the upload file button. The reason we hide it is that because by default, the file input may contain like a collection of like a text field and a button and a label, and that's not something we want to show. We only want to show a button called upload. So that's what we do here. And clicking on this upload button will then trigger the opening of this input. So clicking on the upload button will actually trigger the opening of the file selection dialog. And then we have a preview and overlay divs. Preview is where the viewer itself will be hosted, and preview is a div that will cover the entire page and will be used to show notifications. That's pretty much it. All right, so let's create the final piece. That's our main.css style sheet file. And we can grab it from the tutorial. This is what it looks like. So it's a pretty standard style sheet setup where we just make our HTML page and page body cover the entire real estate with no margin, no paddings. We also try and use an artifact element font just to keep nice UI consistency, because this font will actually be loaded by the viewer as you're loading in the viewer's style.css file. That will actually bring in new type of font called artifact element that is used inside the viewer UI. So by doing this, we'll make sure that the rest of our page is actually using the same font as the viewer itself. And then we just position the div elements, the header, the preview, and the overlay using absolute positioning. We keep the header quite narrow at the top. Standard setup. Okay. And then to show some sort of a logo and maybe a web page icon, you can refer back to the tutorial where you'll find links to a PNG image with logo and a fav icon file. So let me grab this one and save it. To our Bootcamp projects. That's the tab icon. And the logo, you can also say logo.png. You can add your own, you can exclude the fav icon entirely. It's up to you. So what we did is we just downloaded an icon and PNG image from the tutorials. And that should be it for our application. Let's give it a try. We start the app. Go to localhost 8080. Now, finally, this should work because when our server application gets a request for localhost 8080 without anything else, it will actually try and look for the default file, which is typically called index.html. And it will find it in the www root subfolder. And also, as you can see, we already have one item in our dropdown. That is the Revit file that I had uploaded earlier using the Forge VS Code extension. Now let's see if we can actually get this working even from our app. So you can see we have an upload button, and here next to it, there is a hidden file input HTML element, which will get triggered when we click on the button. If I click upload, see now I'm being prompted to select a file. So let's say I'll choose one of these. And now I'm going to be notified that the DWG file is being uploaded. And now if I try and switch to the architectural DWG file, I'm actually going to get a notification saying that you need to wait. The model is being translated. And when it's done, we can actually, the notification disappears and the architectural DWG drawing file gets loaded into the viewer. That's it. So now again, you can see that now we have two designs available in our bucket. So two designs appear in our dropdown. We can switch between them as much as we like. And the interesting part, if you remember from earlier, when we were trying to capture the hash parameter of the URL, you can actually see that that's happening here. So we have our localhost 8080 page, and then we have this hash sign followed by the URN of the currently loaded model, which is quite nice because let's say you would like to share this link with somebody else, right? But if you only tell them to go to localhost 8080, the viewer will go to the first design that it finds, which is this Revit basic sample project. But if we include this hash, the URN in the hash parameter, and share this with somebody else, when they follow the link, the application will actually initialize the viewer, but then it will automatically load the design that we want. So it's a nice little improvement where you want to send somebody a link to look at a specific design, then you can just send them the link and that's it. You don't need to tell them, go to localhost 8080 and then open the dropdown and select some file that can potentially be somewhere far, far down. And that is it. And again, just double check that everything is working as expected. We can go back to our Forge Viewer extension, Forge VS Code extension. And now if we refresh our list of buckets and objects, we should see two files, right? So the Revit file is something we uploaded earlier using the VS Code extension. And the drawing is something that has just been uploaded by our custom Forge application. And again, you can preview it here directly as well. All right, any questions, any problems? Has everybody been able to get this tutorial up and running? I hope, okay. So I hope this was useful, helpful. Have you learned something new today? Hope we've convinced you that this is definitely something worth trying. And awesome. All right. So thank you very much. And I think I'll stick around for a little bit more time to see if there are any questions. I see there is one now. So thank you for your attention. Let me go back just to quickly wrap up with our slides. So again, the rest of the week, tomorrow we'll be covering another tutorial that we call Hub's Browser. That'll be similar to this one, but it won't be about uploading designs and translating them. This time it will be actually about building an application that users can log into with their existing Autodesk credentials, and they can use your application to view their data in other Forge-based products, such as Fusion Teams or BIM 360. And they can access their designs through your app, potentially customized app, as we'll see on Thursday, when I'll be leading a tutorial, the webinar on the dashboards tutorial. And this is where you'll be able to take the either the application you built today or the application you'll build on Wednesday. And you'll be able to start customizing the viewer experience to, again, add your custom functionality to the app as well. And finally, on Friday, my colleagues will lead .NET and Node.js webinars on a tutorial that we call configurators. This is where you'll be using another service inside Forge, specifically the Forge Design Automation service, that you can use to actually create or modify designs in the cloud. Okay, if you need more help, we definitely recommend checking out some of our official learning resources and support areas. We are trying to be very active on Stack Overflow. So if you have any technical questions that you feel are okay to share and ask publicly, definitely check out Stack Overflow. Use one of the labels or tags mentioned here, Autodesk-Forge or Autodesk Viewer, for example. That way, when you ask a question, we'll get notified, and one of our team members can jump to Stack Overflow and answer a question there. If you have something that, if you need help with something that's more individual, more specific to your solution, or maybe more confidential, you're also welcome to reach out to us through an email. If you go to the developer portal under the support get help section, you'll be able to send a message that will come to us as an email into our ticketing system. And again, we can then help you that way in a more private way. All right. And again, what to expect after the event. You can expect an email from my colleague where we will wrap up the session, the webinars, the event. We'll provide links to recordings of these webinars on YouTube. We'll also provide the slides that I've used and that we'll be using throughout this week in a PDF format. And we will also provide a link to a survey. Again, going back to what I was saying earlier, we would really appreciate any feedback you would have on the content, on the format of the event, everything. We still want to make sure that this event, works for you and that you can get most out of it. So please let us know if something that you think was working well, or if there's something you think could be done better. We want to hear everything. And also, if you head over to the Forge developer portal, you can find some additional resources and different paths of improving your Forge skills. We run different types of events as well. Apart from the bootcamp, we run something called Forge Accelerators, which is a week-long event where you can submit some kind of an idea, something you would like to build within the time frame of 1 week. And then we invite you to join us either virtually on Slack or even in person in one of our offices around the world. And we help you implement that idea within that 1 week. So this is really good if you have some idea about a prototype, something you think could be interesting to build with Forge, and you come and join us, and we're basically like Stack Overflow live. So we answer your questions right there, right then. You can also check out the blog. You go to forge.autodesk.com/blog to find our articles on some more specific use cases and workflows. For example, if somebody's interested in loading point clouds into a viewer, like about this very specific question, you can find blog posts on that topic on our blog as well. All right, and with that, I thank you for your attention one more time. This is all from my side. And like I said, I'll stick around for a couple more minutes to see if you have any final questions.